Everything nowadays is moved to the cloud, running on the cloud, or is stored in the cloud. Hence, the demand for certified cloud practitioners is increasing across all sectors of the economy, and it has now become an essential skill that you need to make it in the web development industry. Hi all, I welcome you to this Edureka session, which will serve as a roadmap to the AWS Cloud Practitioner certification. The main objective here is to be able to prove that you can work with cloud computing and with AWS. So you're going to have a lot more job opportunities available to you. So before we begin, let's address a few questions that you all might have about the CCP or the Certified Cloud Practitioner to determine whether it's the right certification for you. So the CCP is all about the foundational knowledge, and what that means is that it can show stakeholders that you know your way around the AWS console. You know the general offerings from AWS, and it's like a light version of the Solutions Architect Associate, which is another certification offered by AWS. But CCP has some very unique offerings which no other certification on AWS platform have, which is that it has a strong focus on billing and business-centric concepts. And that is why it makes a lot of sense why a lot of people who try to obtain the CCP are in sales or management, because it's going to give them the knowledge to help inform stakeholders and business leaders the reasons as to why they should use AWS. So the next thing that probably might confuse a few people is that why should they get this certification? Firstly, it's one of the easiest AWS certifications out there. So if not anything, it should definitely give you a confidence boost. It basically adds to your certification count superficially if that's something your companies care about, and that is why you don't see a lot of developers doing this certification. The second thing is it gets you familiar with your test and its environment. Now, if you're somebody that aspires to take the Solutions Architect Associate exam, you wouldn't want that to be your first exam, because it could prove to be pretty hard in an unfamiliar environment. But like we discussed before, this is a way simpler exam to approach. After succeeding in the CCP, you could definitely proceed to prepare for the Solutions Architect Associate or any other advanced certification. Moving on, let's discuss how long would you take to prepare for this exam. Now, if you are a developer, you're already working in the industry, you can pass this exam in less than a week. You need about 8 hours of structured practice, and that should do it for you. If you are a bootcamp graduate, we'd recommend about 15 hours, which is equivalent to a week and a half of studying and practice, and you shall be good to go. Finally, if you're from the sales and management background, you probably do not have a lot of developer experience or experience with the cloud infrastructure. So we're looking at about 20 hours of study, but once you get a grasp of the concepts, it should be fairly easy for you to crack this examination. And it's not really a huge time requirement. These numbers are just to give you an idea of the rough amount of time you need to put in to prepare for this examination. Moving on, let's discuss a few exam details. Now, you can take this exam in person at a test center or online through a proctored exam. The cost of this examination is $100, and it is the most inexpensive of all the certifications in the AWS suite. Its duration is 90 minutes or an hour and a half, but it shouldn't actually take you that long to finish your exam. So optimize your time and make sure you review all of your answers before you submit. There will be 65 questions for you to answer, and the passing score is 70%, which actually is quite a hard number. And once you get certified, the certificate is valid for 3 years. So that's quite a long time. So there you go. Hopefully, this answers all the questions that you have had about the Certified Cloud Practitioner. With that, let's move on to the outline of this session. So we start out with some fundamental cloud concepts. We are going to discuss what is cloud computing, certain advantages and benefits to cloud computing, the different types, as well as deployment models in cloud computing. Next, we shall be introducing you to the AWS Cloud infrastructure. We'll give you a map overview and discuss other important concepts such as regions, availability zones, edge locations, so on and so forth. We shall also get started on our AWS account, change our IAM user, activate the MFA on the root account, create individual user, and see how to set a password policy. Next, we shall move on to our hands-on section where we shall discuss the AWS Elastic Compute Cloud or the Amazon EC2, Amazon Machine Images, Auto Scaling Groups, Elastic Load Balancer, the Amazon S3 or Simple Storage Service, AWS CloudFront, the Amazon RDS or the Relational Database Service, and finally, AWS Lambda. Then we shall have a technology overview where we shall discuss AWS networking, database services, provisioning services, computing services, storage services, business-centric services, as well as logging services. And finally, we shall talk about billing and pricing in AWS, where we shall discuss the various pricing models, the AWS Marketplace, and the AWS Pricing Calculator. With that, I come to the end of our agenda for today. Kindly take up this time to subscribe to us and don't forget to hit that bell icon to never miss an update from the Edureka YouTube channel. Also, for different tools and technologies under AWS, don't forget to check out our AWS certification training, the link to which will be given in the description box below. So without much ado, let's get started.
Firstly, let's understand why cloud. To understand this, we need to understand the situation that existed before cloud came into existence. So what happened back then? Well, firstly, in order to host a website, you had to buy a stack of servers. And we all know that servers are very costly. So that meant we ended up paying a lot of money. Next was the issue of traffic. Now, as we all know, if we are hosting a website, we are dealing with traffic that is not constant throughout the day. And that meant more pain. We would understand that as we move further. And the other thing was monitoring and maintaining your servers. Yes, this is a very big problem. Now, all these issues, they led to certain disadvantages. What are those? As I mentioned, servers are very costly. Yes, the setup was again costly, and thus you ended up paying a lot of money. And there were other factors contributing to this point. Let's discuss those as well. One, troubleshooting was a big issue. Since you're dealing with a business, your prime focus is on taking good decisions so that your business does well. But if you end up troubleshooting problems or you focus more on infrastructure related issues, then you cannot focus more on your business, and that was a problem. So either you had to do multitasking or you had to hire more people to focus on those issues. Thus, again, you ended up paying more money. As I've discussed, the traffic on a website is never constant. And since it varies, you are not certain about its patterns. Say, for example, I need to host a website, and for that, what I decide is I'm reserving 2 petabytes of total memory for my usage based on the traffic. But as the traffic varies, there would be times when the traffic is high and my whole 2 petabytes of data is consumed or space is consumed rather. But what if the traffic is very low for certain hours of the day? I'm actually not utilizing these servers. So I end up paying more money for the servers than I should be. So yes, upscaling was an issue. So all these things were an issue because we were paying more money, we did not have sufficient time to take our decisions properly, there was ambiguity, there was more trouble monitoring and maintaining all these resources. And apart from that, one important point which we need to consider is the amount of data that is being generated now and that was being generated then. Then it was okay. But nowadays, if you take a look at it, the amount of data that is generated is huge. And this is another reason why cloud became so important. Yeah, as I've mentioned the data. Now, we all know that everything is going online these days. And what that means is we shop online, we buy food online, we do almost everything that is required, as in whatever information we need, we get everything online. Your bookings, your reservations, everything can be taken care of. That means we have a lot of data that is being generated these days, and this is digital data. Back in those times, we were communicating through verbal discussions and all those things, so through paperwork, and that was a different data to maintain. Since everything is moving on cloud or moving online, the amount of data that we have is huge these days. And then when you have this huge amount of data, you need a space where you can actually go ahead and maintain this data. So yes, again, there was a need of this space. And all these issues, that is your cost, your monitoring, your maintenance, providing sufficient space, everything was taken care by cloud. So let us try to understand what this cloud is exactly. Well, think of it as a huge space that is available online for your usage. Now, this is a very generic definition to give you. To be more specific, I would be saying that think of it as a collection of data centers. Now, data centers again are a place where you store your data or you host applications basically. So, when you talk about these data centers, they were already existing. So, what did cloud do differently? Well, what cloud did was it made sure that you are able to orchestrate your various functionings, your applications, managing your resources properly by combining all these data centers together through a network and then providing you the control to use these resources and to manage them properly. To make it even more simpler, I would say there was a group of people or organizations basically that went ahead and bought these servers, these compute capacities, storage places, compute services, and all those things. And they have their own channel or network. All you have to do was go ahead and rent those resources only to the amount you need it and also for the time that you need it. So, yes, this is what cloud did. It let you rent the services that you need and use only those services that you need. So, you ended up paying for the services that you rented and you ended up saving a lot of money. The other thing is these service providers, they take care of all the issues like your security, your underlying infrastructures, and all those things. So you can freely focus on your business and stop worrying about all these issues. So this is what cloud is. In simple words, it's a huge space which has all these services available, and you can just go ahead and pick and rent those services that you want to use. So what is cloud computing? Well, I've already discussed that. Just to summarize it, I would say it is nothing but an ability, or it is a place where you can actually store your data, you can process it, and you can access it from anywhere in the world. Now, this is an important point. Say, for example, you decide to choose a region for your infrastructure somewhere in US, maybe in India, and you can still have access to all your resources that is there in US. All you need is a good internet connection. So that is what cloud does. It makes the world accessible. It lets you have your applications wherever you want to and manage them the way you want to. So this was about cloud computing, guys. Next, we would be discussing different service models. Now, you need to understand one thing. You're being offered cloud services, the platform to use your services or your applications basically. But then different people have different requirements. There are certain people who just want to consume a particular resource, or there are certain people who actually want to go ahead and create their own applications, create their own infrastructure, and all those things. So, based on these needs, we have particular service models, that is, your cloud providers provide you with a particular model which suits your needs. So let us try to understand these models one by one. Well, we have these three models, that is your IaaS, your PaaS, and your SaaS. I would be discussing them in the reverse order. That is, I would be talking about SaaS first, and then I would go upwards. So let us start with SaaS or SaaS. SaaS is nothing but a software as a service. Now, what happens here is basically you're just consuming a service which is already being maintained and handled by someone else. To give you a valid example, we have a Gmail. All you do is you send mail to people and you receive mails. And whatever functionality you do is you just use the service that is there. You do not have to maintain it. You do not have to worry about upscaling, downscaling, security issues, and all those things. Everything is taken care by Google. Say, for example, your Gmail is what I'm talking about. Google manages everything here. So all you have to worry about is consuming that service. Now, this model is known as software as a service, that is SaaS. Next, we have PaaS, that is platform as a service. Now, here you are provided with a platform where you can actually go ahead and build your own applications. To give you an example, we have our Google App Engine. Now, when you talk about Google App Engine, what you can do is you can go ahead and you can create your own applications and you can put it on Google App Engine so that others can use it as well. So in short, you're using the platform to create your own applications. And lastly, we have IaaS, that is infrastructure as a service. Now, what do I mean by this? Well, the whole infrastructure is provided to you so that you can go ahead and create your own applications. That is, an underlying structure is given to you. Based on that, you can go ahead and choose your operating systems, the kind of technology you want to use on that platform, the applications you want to build, and all those things. So that is what an IaaS is, infrastructure as a service basically. So these were the different models that I wanted to talk about. I hope it is clear to all of you. Now, this is the architecture that gives you a clear depiction as in what happens as far as these service models are concerned. Now, you have something called as your SaaS. Now, here, as you see, all you're doing is you're consuming your data, that's it, or using it. Everything else is managed by your vendor, that is your applications, runtime, middleware, OS, virtualization, servers, networking, everything. As far as your PaaS is concerned, your data and applications are taken care by you. That is, you can go ahead, you can build your own applications, you can use the existing platform that is provided to you. And finally, you have your IaaS. Now, what happens here is only the basic part, that is your networking, storage, servers, and virtualization is managed by your vendor, deciding what middleware, OS, runtime, applications, and data that resides on your end. You have to manage all these things. That is, you're just given a box of car, for example, or maybe parts of car. You go ahead and you fix it and you use it for your own sake. That is what IaaS is. To give you another example, think of it as eating a pizza. Now, there are various ways of doing that. One, you order it online. You sit at home, you order the pizza, it comes to your place, you consume it. That is more of your SaaS, that is software as a service. You just consume the service. Next is your platform as a service. Now, when I say platform as a service, you can think of it as going to a hotel and eating a pizza. Say, for example, I go there, they have the infrastructure, as in I have tables, chairs, I have to go sit, just order the pizza, it is given to me, I consume it, and I come back home. And IaaS, now this is where you go ahead and bake your own pizza. You have the infrastructure, you buy it from somewhere or whatever it is, you use your pizza, you put it in an oven, you put spices, all those things, and you eat it. Now this is the difference between these three services. I hope that now it is a little bit more clear to you. So let us move further and discuss the next topic, that is the different deployment models that are there. Now, when you talk about deployment models, you can also call them as different types of clouds that are there in the market. We have these three types, that is your public cloud, your private cloud, and your hybrid cloud. Let us try to understand these one by one. Now, as the name suggests, the public cloud, it's available to everyone. You have a service provider who makes these services or these resources available to people worldwide through the internet. It is an easy and very inexpensive way of dealing with the situation, because all you have to do is you have to go ahead and rent this cloud and you're good to use, and it is available publicly. Next, we have the private cloud. Now, this is a little different. Here, you are provided with this service and you can actually go ahead and create your own applications. And since it's a private cloud, you're protected by a firewall and you do not have to worry about various other issues that are there at hand. And next we have our hybrid cloud. Now it is a combination of your private cloud and your public cloud. Say for example, you can go ahead and build your applications privately. You can use them, you can consume them, you can use them efficiently. When you sense that peak in your traffic, you can actually move it to public. That is, you can move it to the public cloud and even others can have access to it and they can use it. So these are the three basic deployment models that are there for your exposure or your usage rather, and you can go ahead and use those as well. I hope this was clear to all of you. So let us move further and try to understand the next topic, that is different cloud providers that are there in the market. Now, as I've mentioned, what happened was since cloud came into existence, quite a few people went ahead and they bought their own infrastructure and now they rent these services to other people. And when you talk about this infrastructure, there are quite a few people out there who are actually providing these cloud services to different people across the globe. Now, when you talk about these cloud providers, the first thing that should come to your mind is Amazon Web Services, because it is highly popular and it leaves other cloud providers way behind. The reason I'm saying this is the numbers that talk about Amazon Web Services. To give you an example, if you talk about its compute capacity, it is 6 times larger than all the other service providers that are there in the market. Say, for example, if you talk about the other service providers in the market, if their compute capacity combined was X, Amazon Web Services alone gives you a capacity of 6x, which is huge. Apart from that, it's flexible pricing and various other reasons, that is the services it provides and all those things. It is rightly a global leader. And the fact that it had a head start, that is, it started way before many other services that are there in the market, it actually gained popularity. And now we see quite a few organizations going ahead and using Amazon Web Services. Apart from that, we have Microsoft Azure, which is a Microsoft product. And we all know that when Microsoft decides to do something, they expect that they kill all the competition that is there in the market. It is still not in terms with Amazon Web Services or few other service providers that are there in the market, but not very neck to neck. But It is probably the second best when you talk about Amazon Web Services or the cloud service providers in the market. So, yep, it has a lot of catching up to do when you compare it with Amazon Web Services, but it is still a very good cloud service provider that is there in the market. Then we have something called as Google Cloud Platform. Again, a very good cloud provider in the market. Now, why am I saying this? We all know the infrastructure that Google has to offer to you. It is one of the best search engine that is there in the market, and the amount of data they deal with every day is huge. So they are the pioneers when you talk about big data and all those things, and they know how to actually handle this amount of data and how to have an infrastructure that is very good. That is why they have a very good facility, and that leads to it being one of the cheapest service providers in the market. Yes, there are certain features that GCP offers which are better even than Amazon Web Services when you talk about its pricing. And the reason for it is it has various other services that are there. What it does is it helps you optimize various costs. How? It uses analytics and various other ways by which it can optimize the amount of power you use. And that leads to less usage of power. And since you're paying less for power, that is, providers are paying less for power, you end up paying less for your services as well. So that is why it is so cost efficient. Then there are other service providers, that is, we have DigitalOcean, we have Terramark, we have IBM, which is again very popular.
Now, if we talk about the entire architecture for AWS, as we know, AWS has a long list of services that we have the access to. AWS has more than 150 plus services spread in different categories for computation, for databases, for IoT, for AI/ML, for data migration, for analytics, for databases, for networking, computation, enterprise applications, for storage. Now, being a solutions architect doesn't mean, and even for the certification, it doesn't mean that we have to be well aware of every service deployed here. It doesn't mean even the professionals, they don't have the experience of every service. I have been in this industry for almost a decade now. Even I don't know all the services. I have spent almost a decade on using AWS platform. So there are multiple, because earlier they used to be less than 50 services. Now they have been adding more and more services. They have been improvising the existing resources as well for keeping up on the requirements development as of now. And that's why we have to focus on those core services that is going to be used. And in terms of the entire architecture followed by AWS, now AWS has multiple advantages. We know that it is cost effective, because the entire model here depends upon pay as you go model. And since it has been the global leader in the market, that means we can have a complete control on the architecture, or I can say the services and the quality of support we can expect from the global leader, being the advantage of AWS. Now, if we talk about the entire architecture for AWS, then we have the entire architecture of AWS divided in multiple regions and availability zones. Now, when we talk about regions and zones, let's understand the basic idea of these, because these topics are really important even in terms of certification point of view. Although you won't be asked, okay, what is region and what is zones? You won't be asked this kind of question. But once we are working on different services, let's say when we are working on S3, when we are working on deploying resources in every region and zones, then we have to understand why we are doing this in regions and zones and what is the idea behind it. Because the entire certification is also structured on the concept of real life use case, because we get scenario based questions. We don't get these subjective questions, we get these scenario based questions. And that's why it is important to understand these concepts. So let's understand the concept of regions and zones in the simplest format possible. So let's say we are deploying an architecture. Let's move to our annotation mode. Let's change the color of the pen. All right. Let's say when we are working on deployment of the applications, when we have an application, let's suppose we are getting users from all around the globe. Let's say we are getting users from North Virginia. We have used, or we can say we have deployed a single data center in Mumbai. Suppose in the entire globe, we have deployed our entire data, we have deployed the entire application in a single data center, let's say suppose available in Mumbai. And we have users coming in from globally, from different regions. we have been getting millions of requests from the users who are coming, let's suppose, from North Virginia, from Johannesburg, from Frankfurt, from London, from Tokyo, from Moscow, from Singapore. We have users coming in from Sydney, from Taiwan. So we have users coming in from all parts of the globe. And the requests from these different parts of the globe, they all are getting served by a single server. That means if millions of requests is coming down to a single server, that means we are creating a situation of bottleneck. That means we are simply jamming up the entire server and we are putting so much load on a single server that is bound to fail. It is bound to fail. And if we have a large scale application being deployed and if a single server fails, that means our entire application is going to go down. So instead of doing that, what we can do, we can deploy the resources. That's why AWS has divided its entire infrastructure in multiple regions, and in those regions in multiple availability zones. So when we talk about multiple zones, let's say here if we have users coming in from, for example, let's suppose from North America, then we have a zone available for them. Let's change the color of the pen. So for example, we have users coming in from North America, then we may deploy the resources in a region closer to them. Let's suppose in North Virginia, in Ohio, in California. So that any user coming from this particular region, they will be, instead of going down to Mumbai, the application performance is going to be much better if they are served from the region closer to them, right? That's why we always prefer in choosing a region which is closer to our end users. So here we can deploy the resources copy in a region closer to, suppose, to Mumbai. We can deploy a copy closer to Singapore. We can deploy the resources in a region of Singapore in Sydney, which is, and we can say any user coming from any of these regions, instead of getting served from a faraway region, they can be served from the region, the copy of the application served closer to them, so that we can reduce the amount of latency and we can improvise the entire efficiency of the application being used. Every region, they also have multiple availability zones. So just like when we say we are living in a given state, that means we are obviously in a given state, we are also living in a city, because obviously when we say we are living in a state, we have to mean that we are living in a city as well, city or a district. So basically here we can specify in each and every region, we have multiple availability zones that we know we commonly abbreviate as AZs, as in availability zone. So we have some regions, they have 2 zones, some regions they have they have 3 zones, some regions they have 4, some regions they also have 6 zones. Like in North Virginia, we have 6 zones. In Mumbai, we have 3 zones. In Tokyo, we have four availability zones. Now, why we have these multiple zones? To increase the availability and to increase the fault tolerance of a given application. That means for any reason, if the data is not available if one zone is not available, then we can access the same data that is deployed in multiple zones, so that we can improvise the entire availability, plus we can ensure the fault tolerance of the data set that we are going to deploy in a given region. And that's why they are multiple zones, there are multiple regions spread globally as a part of the entire AWS infrastructure. And then we have something called as edge location. So let's understand the concept of edge location first. So, or we can say, let's revisit the component of edge location. So let's say we have a S3 bucket. So now we have seen something as point of presence, or we can refer this as edge location. So let's understand what exactly these components are. So let's understand this by discussing a use case, a scenario. Now, let's say we have a bucket. We have a S3 bucket deployed in, let's suppose, a North Virginia region. We have a S3 bucket deployed in North Virginia. Now, when we talk about S3 bucket, now please do not get confused, because S3 bucket is simply like a storage service that we are going to discuss as we move further into our sessions. So S3 is the same like a Google. We can say we have a Google Drive, so we can use these buckets to have these services being deployed. All right. So let's suppose we have deployed this in North Virginia region. So here we have deployed this entire bucket in the North Virginia region. Now let's say we have users coming in from Tokyo. We have users coming in from Mumbai. We have users coming in from, let's suppose, from Singapore. Now we have the entire data available in North Virginia region, but we have users coming in from different parts of the globe, correct? And when we have now these users are far away, that means they are far from the region in which we have deployed the entire bucket. So the traditional method was we can either deploy a copy of the bucket. The traditional method was for reducing the latency, we can either deploy a copy of the bucket and we can have the bucket deployed in Tokyo. We can have another copy deployed in Mumbai. We can deploy another copy of the bucket in Singapore so that they all have the access to the local bucket. So instead of going all the way down to North Virginia, they can access the content from their own bucket itself, deployed in their own region. So this is the traditional method. But when we are making the copy in multiple regions, then this is going to increase the cost of our resources as well, which we definitely do not want. So what we can do, we can use a concept of edge location, or we refer this as point of presence, POP, or we call it as edge location. So we call it as point of preference or point of presence in the infrastructure, or we refer this as edge location. We refer this as edge location. So these edge locations are the, we can say, mini data centers spread globally by AWS. So we have edge locations spread in almost every country, in almost all the major cities of each and every country. So we have multiple edge locations spread globally. So for example, let's suppose if any user is trying, and now we can enable this service, which is delivered to us by using a service called as CloudFront. So CloudFront is basically like a content delivery network, which we can use for giving us the access to store the copy of our data in these edge locations. So for example, we have a data stored in S3, and now we want to improvise the delivery for the data. Then we can, and using this service called as CloudFormation that we are going to discuss in detail as we proceed further. So using this CloudFormation service, if there are some static data stored in S3, the data which is not being changed on a frequent basis, then we can have this data stored in multiple edge locations spread globally by using the service for CloudFront. So when we use CloudFront, so CloudFront is going to copy the static data, and this is going to make sure that the copy of the same data is available in multiple edge locations spread globally, so that whenever any user who is closer to these edge locations, for example, we have users coming in from different parts of the globe. So any user who is closer to this location, they will be, instead of getting served from the North Virginia bucket, they are going to be served from these different edge location itself as a part of content delivery service. And that exactly is what we mean by edge location itself, to improvise the latency and then to improvise the performance of the applications, or we can say static data being delivered. And for maintaining the fault tolerance of a given application, we can maintain the deployment method. That means we can deploy the entire method. In the traditional method, for example, if we have multiple users coming in from different place, but again, here data is not static, data is completely dynamic. So in that case, in order to maintain the high availability of the application, what we can do, we can go for multiple methods. For example, to improvise the high availability of the application. Now, first of all, you may have question that why exactly we need to maintain high availability, because there are certain factors which are not under our control, like the current situation of COVID-19. It is completely out of our own control. We have nothing to do. Again, this was completely out of our own control. And that's why we have multiple environmental factors coming in. For example, there may be an earthquake, there may be a flood, and the entire data center may get washed off. Now, there may be multiple hardware outages. There may be multiple software, we can say the entire software may get corrupted. The entire data may get corrupted. The entire network may be out. So again, in these cases, for example, if an entire region is out, we have to make sure that data is stored in multiple regions, in multiple zones, so that if a given region or zone is completely down, then still the application can be accessed from the copy that we have deployed in multiple regions and zones. That's the main idea of maintaining this high availability of the application. And the way to implement the high availability is, there are multiple ways depending upon the budget. Because see, AWS itself is not going to make sure that our data is available in every region, in every zone, because that requires cost, because that incurs cost and we have to pay for it. So depending upon how much of budget do we have, we can choose between any of the options available to maintain the high availability. So first of all, we can go for multi-instance. So in multi-instance, we can deploy one, for example, if we are deploying multiple servers, if we have one server deployed, so to maintain the availability and fault tolerance, we can deploy 2 copies of the servers in the same zone. So that if one copy is not available, then the users can access the application from the copy deployed in some other zone. Then we have multiple zone deployment also available. That means here we can look for multi-zone, as in if one particular copy is not available. For example, if one copy is not available, still the users can access the application from the copy deployed in some other zones as well. And then we have multiple regions available. Now, for example, if one zone is not available and if we are deployed in multiple zones, if the entire zone is not available, still they can access the application from the copy that we are deployed in other zone. Then we have multiple region. That means if our budget allows, if entire region is not available, then still we can access the application from the copy that we had deployed in some other region. And then we have multi-cloud. That means if our entire account is not available, then still the users can access the application copy deployed in some other cloud vendors as well. But as we move from multi-instance to multi-cloud, the pricing is also going to increase multifolds, because now we are maintaining the copies across multiple zones, multiple regions, and multiple clouds. But for large scale application, this entire implementation is required, because even a minute of downtime for these large applications means loss of millions of dollars and reputation for the company, which is totally unacceptable. And that's why these make sure that we are using this entire concept for availability. AWS offers us multiple free tier services, and we can use this link for getting to know what all are different services available under free tier. So basically in free tier, we know that we get the access to multiple services by AWS under free tier. Now, when we talk about free tier, we know that we get selective services under limitation. That means, for example, let's say when we are deploying EC2 instance, we get 750 hours of free tier usage. That means we can deploy one server in a given month free of cost. Same way for S3, same way for all the other services that we can explore from the given link. And to sign up for a new account, we can always use this link called sign into the console. If you already have the access, we can click on sign into the console, or we can log in to the account that we have the access to, or we can create a new account and then we can get started. So for creating a new account, here we can click on this option which says create new AWS account. And just like we sign up for any other website, we only have to enter the account name, the username, the password, and then we can get ourselves registered. And we need to have an active credit or debit card, just like we need them while signing up for Netflix, for Prime, for any other services, so that we can authenticate our billing method. And then once we authenticate ourselves, we will be able to get the access to the cloud lab. And for those who haven't signed up, you may be able to log into the account, but again, it may take up to 24 hours for some selective services in this IAM account to be activated, because not all the services are activated by default. It may take up to 24 hours for this account to be fully activated. So as a part of the continuation of journey, we are going to discuss on the components of the IAM service. In IAM, we have, if you talk about the authentication method, then by default, we have two-factor authentication, where we only need to know the username and the password. Whereas in multi-factor authentication, or we refer as MFA, we need to know the username, we need to know the password, and we also need to have the knowledge for any kind of access code or device. Now, this can be an OTP, this can be a security key, this can be an UTF security key, this can be a security card, This can be an iris scanner, this can be a palm scanner, this can be any physical, or this can be a virtual app through which we have the code generated. So why we need to have multi-factor authentication? That means suppose if someone knows our user and password, and especially for the root account and admin account, they can log in and they can perform any activity. They can even delete the entire account if they know the root user credentials. And without the access code, they won't be able to log into the account until and unless they have the security key, or can say security key, or the code or card available with them, which is going to happen in the rarest case. And that's why we have to make sure that we are going to enable MFA for the root and the admin account to keep our entire account secure. So let's see how we can apply that. So let's log into the console here to see how we can set up the MFA. So for setting up the MFA, now MFA has to be set for selective users. We can't define MFA collectively for multiple users. It has to be done at the user level. So here we have to come down to the user dashboard. So here we can see the list of all the users that we have. And here we can click on, for example, we want to define the access for, suppose this one, August 1. So here we can open up August 1. And here in August 1, we can see that a tab called as security credentials. We have to open this up where we can find the summary as in the console login link for this user. If you want to reset the password for this user, we can easily do that by clicking on the manage section. And then we can generate the password, or if you want to assign the MFA for this user account, we have to click on assign MFA, and then we can click on manage. So there are three ways of assigning MFA. We can use the virtual MFA device. We can use an UTF security key, or if we have the access to other hardware device, then we can choose them as well. So for UTF security key, we can, if we do have the access to UTF key, then we have to plug in that key, and then only we can start using it. And then if we don't have the access to UTF key, then we can say if we have any other hardware device connected, then we can use that hardware device. We can say any other hardware to get connected, or we can use any of the application, like we have Google Authenticator, we have Microsoft Authenticator, to use this application as a virtual MFA device. So basically, when we say virtual MFA device, we have certain applications available. Let me showcase the list with you all. So here we have the list of all the supported applications from Google Authenticator. Last, we can say we have the access to Duo Mobile, LastPass, Microsoft. So these all are authenticator-based applications through which we can access the MFA device. So the most popular application used for MFA is Google Authenticator. So here we have to open this application. So this is available for both for iOS and for Android platform both. So we can go ahead and download this platform. So once we download the application here, guys, so this is a screen that we are going to look at in our mobile device. So basically, being the admin, we are creating the account, we are securing the account for example, we are the root user. We are the root user here, and our root user, suppose for the entire account, we have three admins. We have three admins that we are going to add here. We have admin 1, admin 2, and then we have admin 3. And now we want to make the account secure for these three admins. So what we have to do, being a root user, we can initiate the MFA setup for admin 1. That means now there are two ways of adding the MFA for admin 1. So obviously, since they are all going to have their own MFA code generated, so obviously we want them either physically available with us so that they can have the access to their own device and they can scan the QR code which is given to us, or if they are not physically present with us in our office, if they are working remotely, then if they are physically present, then once the application is downloaded, we can ask them to scan a QR code, and from the mobile device they can scan the QR code which we are looking at in our IM dashboard. And if they are not physically present with us, then here we can click on this option which says show secret key. So this secret key is something that we have to share with the admin, and then they have to, instead of clicking on scan a QR code, they have to enter the setup key. And once they enter the setup key, this kind of rotational based code is going to be generated in the application that they have to enter. So for example, if I scan a QR code, let us fetch our phone here, just a moment. So now we have the access to our phone, let's open up the Google Authenticator application. So once we scan the QR code, we would be able to see a set of two codes being generated that we have to enter here. So here we have to enter those two codes consecutively. So we have the first code that we are seeing in our phone, and then we have to enter the second the second code. We have to wait for 30 seconds because in Google Authenticator, the code are based on a rotation basis. So these codes, they expire every 30 seconds. So this code is going to expire after 30 seconds and a new set of code is going to be generated. So here we have to enter two consecutive codes. So we have to wait for this one to be expired. Now we have a new code with us. And once we enter the correct code, we can click on assign MFA, and this MFA is going to be assigned for the account. That means now the user tries to log in, they have to enter the code that they see in the device, then only they can get connected. And for any reason, suppose if they lose the device, then we have to reset. Being the admin, we can reset the MFA for them. And if we lose the device being a root user, then we have to contact AWS team, and then they only will be able to reset the access to us. Now, for keeping the account secure, we do have a service named as KMS. And for now, currently we have been working on the console. Now, whatever activity we have been doing by console, we can do the same set of activities via CLI as well. For example, we have been creating users. If you want to create or if you want to see the list of all the buckets available in a given account, then we can do that easily by specifying the user set and permissions that we have. All right. So for example, let's say we want to access the same console with the same user account. Now we want to access the AWS resources by using the user account for August 1. Now, if you remember, for August 1 user, we have given the access to console, we can say to CLI as well. We have given the programmatic access, and that's why we were given two set of keys. We had the access key, and then we had the secret access key. All right, so for logging in by the CLI, first of all, we have to download CLI in our system. So for downloading CLI, we can use this option such as download AWS CLI. So CLI is something available for all the systems, for Windows and as well as for Mac systems as well. We can go ahead and download the CLI. So we can, now for Windows, we have a simple MSI installer available. So we can download this MSI installer and we can run the installer just like a regular application and have the application installed. If you are running Mac, then we have the bundle package also available for Mac system. So we can download this bundle package, we can execute it, and then we can have the CLI installed. And for Linux platform, we also can download the package and have it. So once we are done installation of CLI, then we have to open up our terminal. So let's suppose here we can open up our terminal here. So terminal in Mac and Linux, and CMD as in command prompt in Windows. And once we are done installing the CLI, we may need a restart for our system if we are unable to see the version being returned to us. So just to cross check if CLI has been properly installed or not, we have to use this command such as AWS -version. So if CLI has been properly installed and configured, we would be able to see the CLI version returned to us. As you can see here, we can see the CLI version returned to us. So we have AWS CLI and the current version defined as 1.16290. That means AWS CLI has been properly installed and configured, and now we can start using it. Now, whenever we are trying to log into our account console, we have to enter the username and password. Without that, we won't be able to log in, correct? Same way in CLI, we also have to log in first into our account. And for CLI, if you all remember, when we had the user account created, we got a key pair where we had the access to a secret access key, and then we had a access key itself. So these two keys are required for logging into the account. So we do have the CSV file that we had downloaded when we had successfully created that account. So let's open up the credential account. Now, as you can see here, this was a user that we have created. I think this is for the different account. Let's say even now when we are working in as a beginner, we may even lose out on the CSV file. That CSV file credential, having the credential may not be available. So if we don't have the access to that file, then being a root user, we have to log into the account and then we have to log into our own account. And for the user, we can see this is the access key ID that we have generated yesterday, correct? So that means now we have discussed that if we do not save the secret access key, then there's no way we can retrieve it if we have lost it. There's no way we can retrieve the secret access key in case we haven't saved the file. So in case the user has lost the access to the secret key, then we have to make sure that we delete this key, we can remove this key, and we can have a fresh pair of keys being generated. So here we can click on create access key, and now we can see for this user, a new pair of access key ID and secret access key has been generated. So now we can download the CSV file, and we have to make sure that we are passing the CSV file for the user for which the account has been created. So we can use this. So as you can see, now we have the access to secret and access key available to us. So here we can have the access key and secret access key, and this is what we are going to use for configuring our account in CLI. So access key is same like a username, and secret access key is same like a password. So first of all, let's enter the secret access key ID here. So for logging into the console, we have to configure the credentials first. And for doing that, we have to use a command set such as AWS space configure. So for setting up the account credentials first, we have to use AWS space configure. And when we are setting this up for the first time, we won't be able to see anything in the key ID. So this is a key for the user account that has already been configured before. And if we are using this for the first time, this will be set as none. We have to start define this for the first time. Now we are going to log in using the account credentials for August 1 user that we have created. So that means we need to enter the access key first. So here we can copy the access key. We can come back to our command prompt. Okay, we have misconfigured. Let's reconfigure it because we have pasted this twice in secret key as well. So again, if you want to, even if we have switched, even if we have configured the user, we can change the user credentials at any point of time. So as you can see here, since we had defined the access key, now it has been changed. So this was the earlier account, and that means the previous account, and now this access key has been changed to the account ID that we defined here. So now if you want to use the same access key, we can define the same access key here. Now here we have to enter the secret access key. So let's copy the secret access key from the CSV file that we had downloaded. We can copy this up. And now this is a secret access key that we have to enter, just like our password. Then we have default region name. Now we know that whenever we are deploying any resource in AWS, for example, when we deploy any resource in AWS, we have to define the region. That means if we are going to deploy EC2 service, then we have to deploy in which region we have to deploy it. If we deploy S3 bucket, then we have to choose which region we have to deploy the S3 bucket. If we are deploying the RDS instance, then we have to mention in which particular region we have to deploy this RDS instance. That means region, every resource is region specific, and we have to define every time in which region we have to deploy this resource. Now we know that we are currently working mainly in Mumbai region. So instead of defining region each and every time, we can set a default region. That means by default, every resource that we are going to create using the CLI, that is going to be deployed in this region until and unless we specify otherwise. So for example, if we have been deploying 10 resources, then it is not going to ask in which region. This is going to take this region as a default region for every resource that we are going to deploy. But if we want to change the region for any resource, then we can specify that at the time of creation of the resource, and that particular resource is going to be deployed in that region itself. How we can create our own custom policies by defining the custom access that we want to attach to the users or groups that we have. And when we are talking about creation of an IAM policy, then there are multiple components, or can say there are multiple elements available in IAM policy as well. We can create the entire policy. So policy is basically a JSON document. When you say JSON, JSON is simply a language, just like we have YAML, just like we have HTML. So JSON, so each and every template that we have in AWS, each and every document, majority of the documents Even if we are creating the templates, they all are written in JSON script. And when we talk about the policy has multiple elements. We have version, statement, effect, action, resources, and principle defined for every policy that we create on top of AWS. So when we talk about the elements of a policy, if you want to see a small hands, we can see a small preview, then this is what a policy looks like. First of all, when we create a policy, we have to define something called as versions. We have something called as versions defined here. So basically, with the introduction to AWS, AWS initially had a previous version of the policy defined. So just like we have two application versions, we have version 1 and version 2. Same way, the initial version of this for this element such as policy, the first version was introduced in 2008, in the year of 2008, at the same day or same day as in 17th of October 2008. So this was the first version, and later AWS, we can say, updated this version to the second copy, which was introduced in 17th of October 2012. And since then, there has been no update in this policy. So we are currently using this version. So whenever we are creating the policy, we have to define the version. That's a mandatory component. And then we can define these statements. That means what exactly is the content of the policy that we are going to create. Here we can define effect as in allow or deny. So using this policy, we can have two types of permissions defined. We can either allow the access to all the actions and all the resources, or we can deny the access to certain, we can say, resources and actions. We can go for allow or denial. We can do both. And here we can, and next we can define action. That means we are going to allow the access to perform to the users or group to perform the activity on, that means to perform what kind of actions. Now, every resource, they have their own list of actions. Every service in AWS, they have their own set of actions. For example, in S3, we have different action categories. We have different category for read actions. We have different actions available in write, in list, in tag. So for example, in S3, we believe S3 is a different service. So it is going to have different set of actions defined under read, different set of actions defined under write, different set of actions defined under list and tagging as well. When we talk about EC2 service, again, since EC2 is a different service than S3, so EC2 is also going to have its own set of actions defined under read, write, list, and tag. So here we can list out this policy is going to allow the users or group, whichever the component is going to be attached to this policy. So this, for example, in S3, then we can define, that means in S3 service, which particular action we are going to allow or we are going to deny, that we can specify here. And we can specify multiple actions, not just one, we can specify multiple actions like we are going to see. And then we have resources, resources as in each and every service can have multiple resources deployed. When we say multiple resources, that means, let's say we have one bucket. Let's suppose we are using S3. S3 is basically used for creation of bucket for storing the data. In simple terms, just like we have Google Drive, we have Dropbox. So for example, S3 is a service, and in S3, we can have multiple buckets deployed. We can create multiple containers for storing our object files. So for example, here we have defined 3 containers. So here we can define for which resource we want to allow the action to be performed. For example, we have this bucket as bucket 1, bucket 2, bucket 3. So if we want that this user should be allowed to perform this action only on bucket 1, then we have to specify the ARN for it. ARN refers to Amazon resource name. ARN refers to Amazon resource name. So basically, resource name is what? Resource name is the unique, we can say a unique name, a unique ID assigned to every resource that we have deployed in or we are going to deploy in AWS, right? So LNT means now we have 4 different categories here. And we have the ARN. ARN refers to Amazon resource name. That is a unique ID given to each and every resource that we deploy in the service. For example, in S3, we have 2 different buckets. So each and every bucket is going to have its own ARN defined. And for example, we want to assign this policy only for this bucket. Then we have to specify the ARN for it. Or if we want that this policy should be applicable to all the buckets, all the resources, then we can simply keep it as an asterisk. Asterisk means all. All right. So here we can define the address here. So let's go ahead and look at how we can deploy and create a custom policy. Let's look at that. So for looking at the hands-on, we can come back to the console. So in console, for creation of the custom policy, we have to go to the IAM service, because policies, users, roles, these all are defined and managed by IAM service. So here we can open up IAM. And once you open up IAM, to see the list of all the policies defined, here we can click on the option for policies. And here we can see a list of all the policies that has been defined in our account. Now, when you say all the policies, that means the policies which are available, which has been made available by AWS, as in the AWS managed policies, and the policy which we may have created as a part of our custom policies. So for now, if we want to expand the policies here, we can see that each and every policy, they are written in JSON code. So each and every policy, they are written in JSON code, having the configurations defined. So if we want to start creating our own policy, we have to click on create policy. And then now at the end, the policy is going to be generated as a part of JSON script. There's no turnaround for that. At the end, policy is going to be generated as a part of JSON's code. So either if we are comfortable in JSON scripting, then we can start coding in JSON right away. Or if we are not comfortable with the coding environment, if we are working mostly as a manager or in the analysis part, then we can take the help of visual editor. We can take the help of visual editor in that case. So here we can take the help of visual editor. We can go to the service. So here we can choose the service. Now currently we have to first of all define we are creating this for which particular service. We are creating this for which particular service. So here we can choose service such as we are building this policy for, let's say, for EC2. We can choose EC2. And then we can choose the action. That means for which particular action we are going to perform on this service. And here we can define the action list. So for example, here we can see the list of, they have different category of actions defined. We have for list, read, tag, write, and permissions management. Now, for example, let's say if we are going to give the full access, if you're going to full access to EC2, then we can keep it to all actions. Or if we want to be selective, for example, we want to give selective actions under read category. So under read, these all are predefined functions, or you can say predefined actions available under EC2. And no, we cannot create our own custom functions. We cannot create our own custom actions because these are predefined by AWS. So for example, if you want to give in terms of read, we want the user or group, whichever we are going to attach this to. So we want them to be able to get only to allow them to get the console output and the console screenshot. That's it. That means they will be able to perform only these two actions on EC2 service that we are going to define here. All right. And same way for example, if you want them to give the access of tags, tag is something that we had discussed already. That means we can allow the users to create tags or delete tags. Tags as in, if we are deploying resources, then they would be able to add tag to them or not. That is at least what we define as a part of tag component. All right. And then same way, if we are going to give a certain access to write, again in write, we have multiple set of actions defined. There are multiple categories of available there are multiple actions available under write, as you can see here. So for different servers, we'll be having different set of actions defined. For example, if you want to give a complete write access, we can choose all the actions, and all the actions are going to be chosen. For example, we want to give the list of the access to all the write actions. As you can see here, there are 260 actions available for EC2 under write category. If you want to give the full access, then we can keep it to full access as well. Depending upon what kind of policy we are going to create, here. All right. And we can choose whatever action we want to give. For example, if we want to be selective, we can be selective in the actions that we choose. We can be selective, or we can define the complete read action, or we can give the action to write as well. So for example, we want the user should be able to read all, we can say perform the read actions, and then they should be able to perform the list options. For example, list as in, they can list the number of servers deployed, they can list the number of resources being deployed one by one. All right, so here we can be specific on the type of action that we want to add here. So let's say we want to give the full access to EC2, then here we can choose full access to EC2. and then we have multiple resources. Now, in EC2, we have multiple resources. We have the VPC, we have the subnet, snapshot, security group, network ACL, instance. These all are a part of EC2 itself. And we have discussed that for every resource, we have different set of actions defined. For example, if we change the service from EC2 to S3, if we change this to S3, we would be able to see a set of different actions defined. Now we are having different list actions, we have different read actions, and we have different list of tagging and different list of write operations also available, correct? Because different service means different service, different actions for which is unique for each and every services. All right. So for example, if you want to be specific, then we can choose a specific actions on the list. We want to give the full action to list. That means user will be able to see the list of all the buckets deployed. Now we want them to have only the read-only access. So here we can set all the actions for read, but we don't want them to have the write access given. Then we can allow them to have to see the list of all the buckets and to read the content available in these two buckets. So here we can be selective in the list of actions that we have chosen. All right. And then we are going to choose the resource. Resource as in this policy is going to be applicable for all the buckets, for all the resources that has been deployed and that will be deployed in S3, or we want to be specific to be to any specific resource. We can do that. So here we can choose the access point. So if you want to be for a specific resource, for example, we want this policy to be applicable only for a certain bucket, then here we can choose the bucket ARN. So for example, we have deployed a bucket by the name of, suppose, July 24. Then we can choose July 24 as the bucket name, and here we can click on add. That means this policy is going to be applicable only for this bucket, not for all the other buckets. And if you want this to be applicable for all the resources, then we can keep it to all. And whatever we do here, we are doing here in this editor, the same thing is going to update. It's the same thing is going to get updated in the code as well. So if you move to JSON code, we will be able to see the entire code has been updated. It contains the effect for allow. And since we have selected certain actions, so here we can see the list of all the actions that we have selected in S3. As you can see here in S3, we have selected these many operations, and all these actions have been added in the JSON code, right? So for example, if we define this for all, then here in actions, if we keep it to all the S3 actions, and now if we come back, we can see the entire list of actions has been replaced by simple asterisk. Asterisk means we are given the access to all the actions available under S3. We are given the access to perform the activity using all the action list. All right. And then once we are done, we can come back to Visual Editor. So in the same policy, now currently we have added S3. If you want to have multiple resources defined here, then here we can click on add additional permission. So currently we have defined for S3. That means in the same policy, if we want, we can attach the access to some other service as well. For example, in the same policy, we want to attach the access to EC2. For example, EC2. Now here in EC2, we want to give the access only to perform read actions. That means only the read actions and the list action. Here we can define or just read operations itself. And now we can define the resource for all. Now you can see here, now we are giving the access to perform read operations on all the resources under EC2. So this is also going to be updated in the JSON. So you can see in S3, we are giving the access to all the resources, whereas in EC2, we are being selective in the actions. That means in the same policy, we are going to add the permissions for multiple services, as you can see here. All right. And once we are done, we can click on review policy. We can define the policy a name. Suppose we define the name as S3. Let's name it as a custom S3 and EC2 policy that we had defined in August 20. And here we can add a description should be added to the resource that we are going to define, because when other users are going to access the same policy, they're going to know, okay, what exactly this policy was all about. And here we can click on create policy, and now the policy is going to be created. So for defining the passive policy, we have to go to the same IAM dashboard, and under IAM dashboard, we have something as account settings. So currently we are going to discuss on the password rotation policy. Let's delete the current policy available. We can delete this policy, and here we can click on set password policy. So this password policy is going to be applicable for every user that is already onboarded, and those users are going to be onboarded. This is going to be applicable for every user. So here we can define the entire policy for. So here we can define how many number of characters we want to define the password for. That means each and every user who are going to be onboarded, they are going to have at least suppose 8 characters of password. Then we need them to have at least one uppercase, one lowercase. We need them to have at least one letter. We need them to have at least one alphanumeric character. We need them to have the password defined for them. For example, we want their password to expire. Now, this is something that you may have observed when you are working on the components, right? So for example, when we are working on net banking, on the government-based website, they all have the password expiration policy defined. That means we have to make sure that we are expiring the password, because as the passwords age, it simply increases the chance of those passwords being hacked. We have to make sure that these passwords expire so that the user, they have to generate a new password every couple of months, most probably in 2 and 3 months. So here, if you want the password to be expired every 2 months, and here we can define 60 days for to be 60. If we want to allow the users to change their own password, we can allow them, or generally for the enterprise account, we keep it disabled. Why? Because it's a proven fact. Suppose if we have forgotten our password, suppose if the users are signed in and they, for example, in Facebook, suppose if we forget a password, we have the option of getting the password resent link in the email ID. And we know that 90% of the users globally, they use the same password for almost every of their account. That's a fact. And suppose suppose if a hacker is trying to access the account and they don't know the password to Facebook, but they have the access to our email. So they can send a reset link by using the option available here. And once the link is sent to the email for which they already have the access to, they will be able to log into our account. And this itself creates a security breach. And that's why we keep this option disabled, especially for the enterprise accounts. If the user forgets a password, they have to contact the admin, and then only they will be able to reset the password for them. And then we can define if you want to disallow the users to use any of the previous passwords for how many times, we can define that. And this password policy is going to be applicable for every user who has already been onboarded, or for those users for which the account is going to be created. So here we can click on save changes, and the password policy is going to be applicable for every user in IAM dashboard.
So for getting started into EC2 service, we have to go to the EC2 dashboard. So once we have logged into the console, we can go to EC2, and this is a dashboard for EC2 that we are going to look at. Now remember, unlike S3, so if you all remember the S3 dashboard, then S3 dashboard is not region specific, right? So if you open up S3, it's simply a global dashboard. When we say global dashboard, that means we can see the list of all the buckets, and we can see in which region we have deployed these buckets, right? We don't have to switch to multiple other regions in other services. But when we log into EC2, then EC2 is basically having region specific dashboards. That means here we can see the list of all the instances. For example, to see the list of all the running instances, we can click on running instance, and here we can see the entire list with us. So if you are looking now, currently whatever list we are looking at, this is based on the region that we have selected. So we can see currently we have an instance deployed. So if we want to now currently we can see the list of only those instances which are currently active in this Mumbai region, And now that means we won't be able to see the list of instances that we have deployed in Singapore. We won't be able to see the list of instances that we had deployed in any other region if we have chosen the region to be Mumbai. So that's why we have to always take care of the fact that we have to make sure that there are no running instance in any of the other region that we may have deployed. So for example, let's say we may have services deployed or instance deployed in Singapore. So for seeing the list of all the instances in Singapore, we have to switch to Singapore region. Then only we will be able to see all the running instances and the resources deployed in Singapore in this dashboard. So suppose if we accidentally launch an instance in Singapore and we switch the region to, let's suppose, Hong Kong or to any other region, then we may even forget that we have a running instance in Singapore region, and that may add up to our billing. So we always have to make sure that we keep a check on the instances based on the region that we are working in. So let's say we come back to Mumbai for getting started. So for creating a new instance, as in a web server, we have to click on this option which says launch instance. So once we click on launch instance, then we would be able to see a 7-step process in front of us. The first one starts with the concept of AMI, which refers to Amazon Machine Image. When we talk about machine image, then it simply means, it's in simple layman terms. Now, when we are creating a system, when we want to deploy anything, when we are deploying a server, obviously we have to choose the OS as well, right? We have to choose an OS. That means in which particular operating system we want to get started. So we have multiple pre-configured AMIs available that we can choose from. So when we are deploying any server, we have to choose whether we want the server to be running on Linux or suppose to be running on Windows platform. I suppose in Linux as well, we have multiple distributions, like we have Fedora, we have Ubuntu, we have CentOS, we have Gentoo, we have Red Hat, we have Kali Linux. So there are multiple other variations also available in Linux. Same way, we have multiple variations available in Windows as well. So we can choose which of these we are going to use as in a base. Again, suppose in Ubuntu, again, we have multiple configurations, we have multiple distributions available that we can choose from. So depending upon, just like in Windows, we have Pro. Again, in Pro, we have Pro for Net. We have Pro, and then we have Pro N as a network optimized. Same way, we have different variations available, and again, in a single variation, again, we have multiple sub variations also available that we can choose from. Suppose if we choose Ubuntu, then the server that instance that we are trying to deploy, that will be deployed or running on top of the Ubuntu image that we can configure further. Or if we want, we can use the complete marketplace as well. When we say marketplace, it means we have multiple configurations, we have multiple pre-configured applications deployed. We have multiple pre-configured applications deployed. For example, we want to deploy a WordPress website or any application running on any e-commerce solution or any deep learning solutions. So there are multiple pre-configured images that we can choose from that has the entire operating system and all the application files as well, so that we don't have to worry about doing the manual installation of these files, and we can use it as a base to continue our development. And these all are available as images that we call as AMI, Amazon Machine Image, because whenever we are deploying any instance, we have to choose the AMI. Without choosing the AMI, we will not be able to deploy the instance. All right. When there are multiple AMIs available that we can choose from. So these are the most popular AMIs. Like we have Linux 2, we have Red Hat, SUSE, then we have Ubuntu server, Microsoft Windows servers that we can choose from. We also have the access to community AMIs, like we have Amazon Linux, CentOS, Debian, Fedora, Gentoo, OpenSUSE, Ubuntu platform. So we have multiple variations available that we can choose from, whichever we want to use to get started. So that these are going to be the base. For example, let's say we are going to deploy a LAMP stack application. Then we can use any of the Linux distribution as a base. And then we can start working on installation of Apache server, PHP servers, MySQL servers, or we can start adding the entire application code, whatever we want to do. So these are going to be used as a base operating system on top of which we can get started. All right. And we also have the access to marketplace. That means when we talk about marketplace and we have blockchain, so basically if you want to deploy blockchain solutions, ML solutions, any analytical solutions, then we can use these pre-configured AMIs. AMIs as in, for example, let's say we are looking to deploy content management services. For example, we are looking to deploy Joomla instances. We are going to deploy WordPress applications, Magento applications, Drupal applications. Now, when we talk about these AMIs, these are also running on top of the Linux or Windows distribution. As you can see, this is running on top of Debian platform. That means when we have a requirement of deploying any WordPress application, then we have to choose a distribution for Linux. For example, here we have to choose Debian, and then we have to install the MySQL because this works on database. We have to install the MySQL instance. We have to install the PHP server. Then we have to manually install and upload all the files of WordPress. We have to install it. We have to configure it. Then only we can start working on WordPress. So either we can choose Debian as a base AMI, and then we can work on configuring these different components manually, or the entire configuration is already available as another AMI. So we can use this AMI to deploy all the services automatically, and then we can start working on customizing the application as per the requirement as well. So that exactly is the concept of AMI here in EC2. Now, after we are done selecting the AMI, so for example, here, let's say we choose the Ubuntu base. Let's say here we can choose Ubuntu AMI. Then we have to choose between the different instance type. We have multiple instance type available. So instance type means the type of, we can say the exact configuration of the instance that we want to deploy. So basically we have general purpose, compute optimized, GPU instances, memory optimized, and storage optimized instances. So depending upon the type of application we want to deploy, we can choose the correct type of instance that we have to deploy. So basically, let's say when we have a computation intensive application that needs to be deployed. For example, in our web server, we are deploying an application that is allowing the users to perform the video editing in the browser itself. Then we can go ahead and then we can choose the compute optimized instances, right? So basically, when we are going to deploy these computation heavy applications, then we do require to have a good support on the computation towers. And that's why here we can get a good support in the number of cores of CPU, plus having the support for the computation intensive requirements. So basically in the compute optimized instances, we get a good processor where we can have the local NVMEs based SSDs with C5 instances. So let me explain you better by using this link as a reference. So basically in this instance, now we have different instance categories. We have compute optimized, memory optimized, storage, and accelerated computing instances. So for computation optimized, we have a better performing processors involved. Here we can have up to 96 cores of CPU attached, where we can have 4 slots of 900 MVM SSDs. In here, we have multiple families available, like we have C5, C5D, C4, and C3 families available in computation optimized. And again, within the family, we have multiple subtypes, like we have for large, for two types, for 4x large, for 9x, for 18x, and then we have for C5 metal, where we can choose exact configuration. Now, these are the pre-configured variations available. That means when we are choosing C5-9, that means here we get 72 GB of memory, where we get 36 cores of CPU, and these are currently based on a 64-bit platform. So here we cannot customize it by default, but again, if we have a large cluster that needs to be deployed, then we can contact the support team and they will be configuring the entire hardware as per our requirement. Same way, when we have a requirement of long running applications, then we can choose memory optimized instances, where we have R5, R5A, and then R5D family available. So basically here we get here we have a support of more than 976 gigs of memory available that we can consume, and then we get the support for multiple cores of CPU as well. So if we have a long running application, if we have a large scale application which requires to have a good amount of memory, then we can use the memory optimized instances. Same way for storage optimized, when we have this is especially what we use for the big data application or for our data analysis jobs, where we want to maintain a good IOPS, as in input output operations happening in our per second basis. There we can use these storage optimized instances, where we get a good performance on the storage that we are allowed to use here. So basically here we can get a good performance on the storage intensive use cases. Same way when we are deploying this for general purpose application, as in when we are deploying a small to medium scale website, then instead of these computation and memory heavy instances, we can choose general purpose, where we have families such as M5, M5A, M5D, T3, T2. These two all instance families are available under general purpose. So basically they offer a good baseline performance in terms of, we can say, a balanced approach between computation, memory, and storage capacity. So we can use this as a good web server that we can use to get started. If we come back to the dashboard, we can choose what kind of configuration we want to choose in order to get started. For example, here we have the access to all the type of instances. with the current configuration defined. Now, in here, when we start our journey on free tier, so in free tier, we mean T2 micro. That means we are not allowed to deploy any compute optimized instances for free as a part of free tier. In free tier, we get the access to only T2 micro. As you can see here, it says free tier eligible. That means 750 hours of free tier access we can get only when we are deploying any T2 micro instances, where we get 1 core of CPU, 1 GB of memory optimized. After choosing the current instance type, we can move further to our next phase, that is configuring the instance. So here we can choose how many instances we want to deploy by using the current AMI and the instance type that we have chosen. We want to deploy 1 instance or 10 instances or 20 instances, we can choose. By default, we can deploy not more than 100 instances in the default account. So we have a soft limit. So we cannot deploy more than 100 instances as a part of the default limit set by AWS. If we have a bigger limit, if you have a bigger requirement than that, then we can contact support team and they will be increasing the limit for us, depending upon our use case. So when we get the free tier access, that means, now when we say free tier, we get the access to T2 micro. That means we can deploy 1 T2 micro instance. We can deploy 1 T2 micro instance, and we can, if we keep it running. So in free tier, we get how much? In free tier, we get 750 hours of T2 micro instance. That means if we deploy 1 T2 micro instance and we keep it running for 24 hours on a daily basis, and we run this for, let's say, for 30 days in a given month. We run this for 30 days in a given month. That means the total usage for this instance is going to be how much? It is going to be for 720 hours, correct? And that means this, if we deploy just 1 T2 micro instance for 24 hours on a daily basis for continuous period of 30 days, then we can keep this instance running for free, because in free tier we get 750 hours of free tier usage, correct? But if we deploy 2 instances, for example, same use case, if we deploy 2 T2 micro instance, and suppose if we run them same for 24 hours daily, and that is for 30 days a month. That means here we are going to consume how much? Almost double, 40 hours. That means in free tier we get only 750 hours of free tier usage. That means the balance number of hours is going to be charged from our account. That means if we want to deploy 2 T2 instances, then we have to make sure that we run them only for 12 hours, so that our consumption can be brought down to how much? To 720 hours itself. Or if we want to run them 24 hours on a daily basis, then we have to pay for the remaining number of hours. That's how the free tier structure is defined in AWS. So here we have the number of instances, and basically we have multiple purchasing options available. So now we are going to discuss pods. So let's have a quick overview of the instance type available in terms of purchasing option. In purchasing option, so basically we go for, by default, we have on demand. When we say on demand, that means if we have a requirement of, when we are uncertain on the number of hours we are going to use the resource for. For example, if we have a small requirement of deploying 20 instances for, let's say, for 200 hours. That means we can deploy 20 instances for 200 hours and then we can scrap it. That means we pay only for the number of hours we have used any server. So if we deploy, let's suppose if we deploy 500 servers and we consume them for 100 hours, that means we have to pay only for running those 500 servers for 100 hours. That's it. Nothing less, nothing more. And then we have reserved instance type. We have reserved. So basically we choose reserved. Let's say we are working for a client and we know that our client is going to consume, let's say, 10,000 hours of EC2 usage in a given year. We know this as a fact, as a part of the agreement that we have signed. And when we have a clear-cut requirement for a specific number of hours on a yearly basis, then instead of paying on demand basis, we can go for reserve instance. That means we can pay for the entire pricing upfront. We can pay upfront for the entire usage that we are going to consume, so that we can save a good amount of money here. For example, let's say on demand, we have consumed these servers, let's suppose, for 100 hours. That means here we have to pay only for using the servers for 100 hours. That's it. Nothing less, nothing more. Then we are going for on-demand pricing. Let me suppose if the current rate of running the instance is, let's suppose, $0.05 on an hourly basis. That means if we have consumed the server for 100 hours, that means here we have to pay 0.05 multiplied by 100. That will be our actual cost that we have to pay for running these servers, as in $5. As in $5, right? So this is what on demand. This is what on demand instance type. But if we know for how many hours we are going to use the current resources, for example, a client is going to consume, let's say, 5,000 hours on a daily basis. So we know as a fact that this resource is going to be used at least for 5,000 hours. So instead of paying on an hourly basis, what we can do, we can buy these 5,000 hours upfront. So using reserve instance, we can pay upfront for the entire usage so that we can save up to even 90% of cost for the running instance. For example, if the conventional rate for running T2 micro is $0.05 on an hourly basis, and if we go ahead and purchase the entire number of hours upfront, then the pricing here may come down to $0.03 per hour as well, 3 to even $0.2 per hour as well if we are going to pay for it. It may be between 0.03 to 0.02 as well. And then we can choose the network that we have. So network is basically we can choose in which, if we are going to deploy multi-tier architecture where we need to have a complete control on what kind of source is going to be allowed the access to this instance, or what kind of security gateway we are going to allow, what kind of firewall we want to allow the access to this instance. And if you want to deploy a complete access control list for the given instance type, if you want to deploy our own intent gateways and NAT gateways, then we can deploy them in our own network. Or we can choose the default VPC which is given to us by AWS. So we can keep it a default for now. And then we have placement group. So placement group is basically like a collection. So if we have a requirement of deploying 5 or 10 clusters, then we can choose a placement group. So we can create a single placement group, so that if we want to stop all the instances on that group together, if we want to perform the activity on the group together, then we can do that collectively by using the placement group. All right. And then we can choose the capacity reservation. Basically, using this property, we can, if we have deployed 10 GB of RAM of instance, right, then we can reserve the capacity so that whenever we require, we can distribute the entire resource accordingly into some other instances, or we don't have to pay entirely for the instance that we deployed. Whenever we feel, okay, now we have a requirement of the resources, that instead of upgrading our server, we can simply remove the reservation, and then we will be using the entire instance with its full capacity. That's how it works here. And then we have the access to roles. Role is something that we have seen. We can create the role. Suppose we want that this instance should be having the complete access to perform the operations on RDS instance. So we can save that. We can save it as RDS, and then we can allow the access to RDS instance for the EC2 instance that we have deployed here. And then we can define the shutdown behavior just like we defined for our normal PC. When we stop the instance, it is going to be stopped, as in when we no longer need the instance for next few hours or next few days, then we can stop the instance, that we can restart at any point of time. But if we no longer need the instance completely, then we can terminate it. So when we terminate any instance, that means that instance is gone. Even if we want to restart the instance, we won't be able to do that at any point of time. All right. So here we can define the entire configuration as per the requirement. And then we can choose to have the monitoring servers. If you want to monitor each and every aspect of the server that we have deployed, then we can choose monitoring service for that. And monitoring is available by another service called as CloudWatch. So CloudWatch is a service through which we monitor all the resources, something that we are going to discuss in our application service module. And then we have tenancy as in shared and dedicated. So we have two types of tenancies available here in AWS. We have shared and then we have dedicated. So let's understand the concept of shared and dedicated as well. Let's come back to our integration mode. And here we have instance tenancy. Let's understand the concept of tenancy here. Let's say here we deployed one server, and in this server, suppose here we are having 1 core of CPU and 1 GB of RAM. 1 core of CPU and 1 GB of RAM. So if you are deploying in the same server, the same server is being used by multiple applications. Suppose if you deploy multiple applications by different accounts, suppose the same server is housing, let's say, 10 different applications. That means all the application, that means we have on the same server, we have multiple applications running by different users. So the performance of all the applications are going to be compromised. Although the pricing here is going to be less, because when we are deploying multiple applications, if we have multiple applications deployed on the same server, then that is called as a shared tenancy. Then obviously here we are compromising on the performance, but here we save a good amount of money because here we are using the shared resources. And secondly, if we are deploying our application on a server where in the server only our own application is deployed, suppose the server is not being used by any other vendor or any other application owner, then that is called as a dedicated tenancy. That means even if we deploy the same server, as in 1 core of CPU and 1 GB of RAM, then we will be getting a good performance out of it. Why? Because this 1 core of CPU and 1 GB of RAM is not being distributed among multiple applications, just like in shared. So the entire server is going to be dedicated only for us. And that exactly is what we refer as dedicated tenancy. And as we know, since it is dedicated, so it costs us more. That means suppose if we deploy any T2 micro instance here, then for T2 micro in shared, we have to pay $0.05 on an RD basis. And if we deploy in the same T2 micro, but on a dedicated instance type, then here we have to pay this $0.05 plus $2 per hour for running the instance on the dedicated resource. So that's exactly what we mean by tenancies. We have shared and then we have dedicated tenancy depending upon the application. So here we can choose what kind of tenancy we want. We can choose between shared and we can also choose between dedicated as well, depending upon the requirement. Next, we have storage. So storage is something that we can now, because every server, just like every PC needs to have a storage defined. Same way, every server also needs to have a storage volume defined. So this entire concept is given to us by EBS, as in Elastic Block Store. So the volumes that we attach, to the instance, these are referred as EBS volume, as in Elastic Block Store volumes. And just like in a single PC, we can attach multiple volumes. So here we can attach multiple volumes as per the requirement. Now we have different type. Now a single volume can be of size between 1 GB till 16 TB in size. TB as in 16 terabytes. And we have multiple volume also available. Like we have general purpose, we have provision IOPS, we have magnetic, we have throughput optimized, and then we have tape as well. So once we have chosen the volume type, we can add tags. So tag is something that we had discussed already in our IAM discussion. So we can attach tags. So for example, if this is a web server, then we can define the type to be web server itself. For example, if this is what, we can define type as web server. If this is for which project, for example, here we can add another tag. This is for which project? This is for healthcare. For example, this is for healthcare project that we have been deploying this for. So we can add multiple tags and then we can click on security group. So security groups are like firewalls. So currently we are deploying an instance and here we can define what kind of protocol, what kind of port range, and what kind of source would be allowed to connect to this particular instance that we have been deploying. So for example, we wanted to give the SSH connection and then we can define the port. So for SSH, we have default port defined as port 22. And if you want that anyone coming from anywhere should be allowed to connect, then we can keep the public IP, we can say the public access, or we can, if you want that only we should be allowed to connect, then we can choose our own IP, or we can define the custom IP as well. If you want to allow the access to some certain IP addresses, that means anyone coming from that particular IP, only they will be allowed to get connected by the SSH protocol. All right. So let's say if we are deploying any web servers or any web-based application, then we know that until and unless we give the access to port 80 and port 80 and port 443, that particular website is not going to be opened up in the browser. So even after deploying the instance, we would be getting the DNS and public IP, but those are going to be of no use until and unless we have given the access for these for the HTTP and HTTP protocols. So for HTTP, we have port 80, and since we are going to deploy the application and users are going to be coming from anywhere, then we can keep it to public. And if we have an SSL base of site that we want to deploy, then we have to give the access to port HTTPS as well. All right. So depending upon, suppose if we are deploying here we can choose our custom TCP protocol. We have the access to HTTP, to SSH, to SMTP, to SMB, and to all the other services as per the requirement. If we are sharing a file structure that we are going to discuss on NFS, then we can choose the NFS protocol as well. All right. Now, once we define the instance type, once we define the AMI, the security group, then we can review all the parameters that we define. Let's say we give the access to port 80 using the HTTP protocol, and let's also give the access to port 80 as well. Click on review and launch. So here we can review all the parameters that we define, and now we can click on launch. And before we can launch the instance, we don't want anyone to have the access to the backend of the server by using SSH connection, because we want to keep it secure, correct? So because we want any user or any of the developers to connect to this instance securely. And for that, we have to make sure that the private key, we are using the private key in order to get connected. So we can choose any of the private key that we may have deployed in the past, or we can choose an existing key pair. So basically, when we are launching the instance, we can create the key pair. So let's say we name it as today's date itself, so that we can avoid having any confusion as August 9. And here we can click on download key pair. So this is going to download the key pair for us, through which we can get connected to the SSH connection that we defined. That means if we are trying to get connected to the backend of this instance using SSH, then we need to have the access to this key. Then only we will be allowed to access the backend of this particular EC2 instance through SSH connection. So once we are done, we can click on launch instance, and the instance with the configuration that we have chosen is going to be launched here.
So let's see how we can deploy that. So we can come back to our console to see how to deploy launch configuration template first, and then by using the template, we are going to launch the auto scaling component. So here we can go ahead, and in this EC2 dashboard, here we have launch configuration. And here we can click on create launch configuration. And first of all, we have to choose the AMI that is we are going to use for launching the new instance. Practically, we use the AMI of the ongoing application that we deploy. So currently, since we are using the dummy, or we can say pre-configured WordPress AMI. So here, for example, we want to launch more servers with WordPress AMI, then here we can choose WordPress. Click on select. Now here we can choose it to be T2 micro. That means what kind of instance we are going to launch. Then here we can define the name of the template, as in we can define, let's name it as launch configuration. We can define the role. If you want to attach any role, we can define that role. For example, we want that applications being deployed here should be having full access to RDS. This is the access that we defined for the original instance that we had defined as a part of our load balancer. We can define it. And then we can add storage. We can define security group, because these all parameters have to be defined when we are adding any instance. And when we can review all the parameters, we can choose the configuration type. And now we are done creating the entire launch configuration template here. And here we can click on create an auto scaling group, because we want to create an auto scaling group by using the current configuration. So here we can choose create auto scaling group with this configuration that we define. We can name the group as suppose auto scaling itself. Now here we have something as group size. So when we are defining load balancers, now in a hands-on, although we have seen how we can attach the instances manually, but practically we do not add the instances manually. We add the instances by using the auto scaling component. For example, when we deploy any application load balancer, so we only create multiple target groups. For example, we want to have 3 target groups defined. So we can create multiple target groups here, correct? And we can attach the auto scaling component to these different target groups. We can attach auto scaling component that we are going to define here. So what they are going to do? So here we can define we want to start with how many instances, as in here we can define we want to start with at least 3 instances. That means auto scaling component here, it is going to automatically launch 3 instances in the target group they are going to be attached to. So for example, if we attach this auto scaling to this group, then this is automatically going to add 3 more instances by using the launch configuration template that we have defined, so that we don't have to add these instances manually. And then we can choose a network in which we want to define this. For example, we want to use a default VPC that we have the access to. We can choose default one. And then we can choose a subnet in which we want these to be deployed. So subnets are like, we can say we have different subnets defined for different zones. So let's say here we can choose, we want to deploy all the instances, either if you want that all the instances should be deployed only in one subnet. For example, now when we're talking about multi-tier architecture, then we may have 1B, we may have private subnets, and we may have public subnets. So we can choose in which particular subnet we want to have this application or all the instances deployed. For example, let's say if we are defining a multi-tier architecture, so we may have web servers, that web servers need to have a public access, so we can deploy them in the public subnet, Whereas if we are using a load balancer for internal use case, for example, the internal load balancer that we had discussed earlier, so in that case, that load balancer is going to be used for application load balancers that are going to be deployed in different subnet. That means these are going to be deployed in private subnet, right? So these are going to be deployed in private. So that is what we have to choose as a part of this auto scaling group, where we can either scale, if you want, we can also scale up and down the private subnet as well, depending upon the requirement. Next, we can define scaling policy. So here we can, if we don't want to apply the auto scaling method, it means we want to simply keep the number of instances to the number that we defined, then all the instances are going to be kept at that number itself. Or if we want to use auto scaling policies, then we want to define when we want the servers to be increased and decreased, then we can here click on this option which says use scaling policies. First of all, we have scale between, and now this is the minimum number and this is a maximum value. For example, here if we define this to be 10, that means here we have minimum number defined. So this is what scale between. Now what should be the minimum value of the instance that you want to be defined? So this is the minimum value, and this is the maximum value. That is how many maximum number of instances we want to deploy in this given target group. That means if we define the minimum number to be 3, for example, in this auto scaling group, so at any point of time, there are going to be at least three different servers deployed. So for example, here we can deploy 3 different instances. So auto scaling is going to make sure that if the minimum has been set as 3, then there should be at least 3 running instances at any point of time. So for example, let's say for any reason, if 2 of the instances, they have been stopped or they have been terminated, now the number is 1. But here in this policy, we have defined we want to maintain at least 3 instances, right? Here we define as a number that we want to maintain at least 3 instances. So what we can do here, we can define here this auto scaling is automatically going to launch 2 more additional servers to match the number of 3 minimum instances, right? And here we define 10. Now, as per the auto scaling logic that we are going to see, we have defined that whenever CPU usage is beyond 60%, it should launch 2 more servers, right? Or suppose multiple additional servers. So now we need to maintain our maximum number of instances, because if we do not do that, then we are going to keep on launching more number of servers. And again, for increasing the performance, we don't have to go over the budget. Suppose if a client has a budget of only $1,000 on a monthly basis, and if we keep on adding more and more number of servers, obviously their pricing is going to be increased, correct? Which we definitely do not want. So that's why we have to define a maximum number. That means beyond, if the total number of instances in this group reaches 10, then there cannot be more than 10 instances deployed in the current scenario. That's how it is going to be structured. And here we can define the scaling options. So for example, here we can define increase group size, and here we can define to be decrease as well. So in increase group size, we can choose the alarm section. So here we can click on create alarm. Now, first of all, we are going to define the increase group size. That means when we want to add more servers, and obviously when the resource usage, we can say, comes back to normal, we also have to reduce the group size as well to maintain the balance between the performance and the pricing as well. So here we can define the increase group size first. We can choose the alarm. For example, let's say we name it as alarm 1. And here we can, here if you wanted to send a notification using SNS, we can define it. We can keep it blank for now. And here we can choose the average, as in, now we can choose whenever the average, minimum, or maximum value for any instance usage, we can define it. So we can define whenever the average CPU usage is less than, for example, is greater than or equal to or less than, or we can define the entire operand operator as per the requirement. So let's say we want to define when the average CPU is greater than, or for example, is greater than 50%, or suppose 60%, and that too for a consecutive period of 15 minutes. That means one period of 15 minutes or 5 minutes as per the logic that we want to define. So here we can create this alarm. That means whenever the CPU usage is going to be higher, is going to be greater than 60% for a consecutive period of 300 seconds, as in 5 minutes, then it should add, suppose it should add one server. Now, for example, it should add 2 more servers. So if we don't want to add these 2 servers in one go, then we can define multiple steps as well. That means if the CPU usage is between 60 and 65, so it should add 1 server. If it goes beyond 65, then it should add one, for example, 1 more server. So we can define this in steps as well. All right. And once the entire CPU and once the entire group size has been increased as per this logic, we also need to decrease the group size as well. For example, after 2 hours, the CPU usage comes back to normal. That means it comes down to 50%. Then in that case, we can simply click on add new alarm. So here we can define the alarm. Suppose here we can define the name of the alarm to be something different, 2v2. And we want that whenever average CPU usage, for example, here we can choose average CPU usage or disk read, disk write operations, or network in, network out. That means here we can choose the parameter based on the CPU usage, based on the IOPS, and based on the throughput, as we discussed for volumes. So depending upon that, we can choose the parameter. And here we can define when the average CPU, suppose it is less than 60%, because earlier we are increasing. Earlier we defined if the CPU usage is more than 60%, then it should increase the group size. So here we can define if the average CPU is less than 60% for a period of 5 minutes, then it should be decreasing the size as well. Right. So here what we have done, now we have 2 alarms. This is for increased group size, and this is for decreased group size. And again, if you don't want to remove all the servers at once, then here we can add a step as well. That means it should remove 1 server when the CPU usage is between 60 and 55. And suppose if it goes beyond 55, then it should add 1 more server to make sure that the entire balance is maintained. So all the servers which were added, they are also going to get removed as well to maintain the balance between the pricing and the performance. So here we can configure notifications. So whenever we want that, whenever any kind of scaling is happening, so we want the scaling to be applied. So here we can define the notification as a part of SNS. SNS refers to simple notification service. So we can use this SNS. We can keep it removed for yes for now. Then we can configure tags. We can review the parameters. And now the auto scaling group has been created. So here we can close it up. Now we have to attach this auto scaling to any of the target groups or any of the classic load balancers that we have created for this one to be functional. So for attaching this, we can click on actions, and here we can click on edit, and then we can choose whichever load balancer we have deployed. For example, we have one classic load balancer. We want this to be applicable to classic. We can choose classic. We want this to be applied to suppose to DG1 and DG2 because these are part of application. So whichever load balancer we want to apply this to, we can apply this as per the requirement. All right. And if you click on save, then this is going to make sure that whatever instance or whatever target group we are going to attach it to, this is going to be applicable for these different configurations. For example, let's say we keep it to just one DG1. Here we can click on save. So currently, whatever logic we defined, we have defined minimum to be 3, maximum to be 10. So the same thing is going to be applied to the given target group. So we come back to target groups here. If we refresh it, can you all see this? We have defined the minimum number of instances should be 3. So that means 3 more instances have been launched by using the same launch configuration template that we defined. And that's why it is highly recommended if we are using this entire platform just for your practice, then these 3 instances are going to be automatically launched by auto scaling group, right? So we are going to see an increased billing if we do not delete this current instance. That means if we do not delete the auto scaling group. So for making sure that we are not increasing the billing, we have to make sure that we are deleting the auto scaling group first to make sure that, because even if we terminate the instance there, the auto scaling is going to continuously launch more and more number of servers because that's the logic behind auto scaling component. It is going to maintain that minimum number of the instances that we have defined here. All right. So once we are done practicing on it, it's always advisable to delete the auto scaling group and delete the launch configuration template as well once we are done practicing on top of it. Now here we have to go to the same section as load balancer. Click on create load balancer. Here we can define application. Just to avoid confusion, here we can define a name as application load balancer as well. We can choose it to be intent facing or internal if we want to distribute load among multiple application servers as well. And here we can define the listeners. If you want to add multiple listeners, then we can define it, or we can keep it to just one. So we're going to keep this just to one for now. And here we can choose a security group that we are going to use for this load balancer for giving the access to port 80. And here we can configure targets. The same concept as network, we have seen how we can create different target groups, and a single target group can be a part of only a single load balancer, not two multiple. So here let's define the name as TG1. We can choose it to be instance. We can define the protocol to be HTTP. Here we can click on register target. So we are going to do the same thing. We are going to create one target group having one instance and the other target group having another instance. And then we are going to distribute the load based on path-based routing as a rule that we are going to define here. So here we can click on WordPress that we are going to add in TG1. And then we are going to create another target group by the name of TG2, where we are going to add another load balancer, another instance. So currently we have this application load balancer that is currently being provisioned. And under listeners, we can see we have defined the listeners, and we can see which rule that we are going to apply here. So this rule section was not available with the network as well, right? So here we can find what kind of rule we want to define for the listeners that we have added in application load balancer. So currently we only have one target group defined. So let's to distribute the load among different target groups, we have to have at least another target group defined here. So here we can click on add. So here we can click on target groups. Target 1, 2, 3 are defined for networks. So let's say we define another target group name as TG2. So here we can define the port as HTTP, and here we can click on create. So now we have TG1 and TG2 defined. So let's open up TG2, and here we can click on targets, and here we have edit. So here we can click on edit. So here we are going to add WordPress is something that we have added in TG1. So let's add Joomla in TG2 on port 80. Click on save. So in TG1, we have WordPress, and in TG2, we have Joomla instance defined. Now we are going to define the rule in application load balancer. So we have to come down to application, and here we can choose the listeners tab. And under listener, we have something as view edit rules. We can open this up. Here we can see the entire traffic currently is being routed to only target group one, not to multiple. So if you want to add, we want to define any kind of path-based routing. So here we can click on add, and here we can click on insert rule. And here we can define conditions. So here we have multiple path-based routing. We can go for query string as well. We can go for source IP as well. So for example, we want to touch path-based routing. Now here we can define if the path contains, suppose if the path contains page one, or the path contains page two. This can be any path. That means suppose if we have a domain name that we are going to map, if domain name contains example.com/page one, then this is going to route the traffic to some other target group. And or if it contains page two, then it should be routing the traffic to some other target group as well. We can define that. So path should be the complete path of the domain of any kind of load balancing that we are going to define here. Basically, we are at the end we are going to use route utility service to map the domain to the domain to map this DNS of this application load balancer with the domain name. So we want that if the path contains page two, page one, or whatever we want to define, we can define them as a part of if condition, and then we can choose if these conditions are met, then the traffic should be forwarded to which target group. So here we can choose TG2, and if we want to add multiple groups, for example, suppose if this would happen TG1, then we could also distribute the load among these two different target groups. For example, here, if we want to achieve 70% of load should be shifted to this one, and 30% of load should be shifted to this one, then we can define them accordingly. So since we have only one target group defined, so we can keep it to just one itself. And here we can achieve group level stickiness. If we want to enable group level stickiness, then we can do that. In case we would have defined multiple load balancers, multiple target groups. So here we can click on save, and here we can click on save, and now the rule is going to be updated. So if we come back, we open the DNS for this load balancer, and in the description we have DNS. So if we open this up, copy this DNS name for the application, we can. So by default, since we haven't defined any kind of logic here, so currently we are being routed to this WordPress instance. But if we apply the logic, suppose if we define page one, then this traffic is going to be transferred to the other instance. Now, why we are seeing this page here? Currently, this has been transferred to Joomla. So if you can notice, suppose if we open up the EC2 instance as an instances, Joomla is 2020 site. So if we copy this up, so 2020 my site is running Joomla, and again this has been routed to Joomla itself instead of being we can say being handled by the WordPress website. Now, why we are seeing not where we are seeing this option as in the requested page cannot be found, because there is now in this Joomla instance there is no page by the name of page one, correct? In this Joomla instance there is no page defined as page one. That's why we are not going to see any kind of pages being opened up. That's why we are not going to see any kind of pages being opened up. Had there been a page by the name of page one, then this would have been displayed as a complete website itself. And we can see here the entire load being shifted. S3, let's open this up. And in S3, we can see the S3 is a common dashboard where we can see the list of all the buckets that we had deployed in every region. And to get started, we have to click on create bucket. So here we can define bucket name, and bucket name has to be DNS compliant name. Now remember, bucket name has to be unique, not just for our own account, but for each and every account that we have on AWS. It has to be unique. That means suppose if we want to create an account here, for example, here we can define July, or we can say August. Let's say we name it as August 1. So we have to make sure that the name should be DNS compliant, as in the given URL, there cannot be any uppercase. We cannot use any uppercase. We cannot have any space. We cannot use any @ symbol. We cannot use any / as well, right? So the same concept is also applicable for bucket name. So whatever we have, so that's why because whenever we create the bucket, our URL is going to be generated for the given bucket if we are hosting a static website. And that's why we have to make sure the bucket name should be unique, not in just our own account, but throughout the entire AWS platform. That we suppose if we are looking for a name and it is not available, then that means that particular bucket may have been deployed in some other account. So we have to wait for them to terminate the bucket, to store, to get it to delete the bucket, or we have to wait, or we have to choose any other name. So here we can now, next is we have to choose a region in which we are going to deploy the bucket. We always have to choose a region which is closer to our end users. We always have to choose a region which is closer to our end users. That means we know that our end users, they are sitting in North Virginia. Then obviously it won't make any sense to deploy the bucket in Mumbai, because if we deploy the bucket in Mumbai and all our users are coming from North Virginia, then they are going to observe a huge amount of latency, as in delay in fetching the files. That means that is going to compromise the performance of the application. So obviously we have to deploy the bucket in a region closer to our end users. So here, let's suppose if we want to deploy the bucket in Mumbai, we can choose Mumbai, or we can choose any other region as per the requirement. And then here we can, if you want to copy the settings from any other bucket, then we can copy it, or we can keep it to no for now. Then we can choose all the properties for versioning, for server access logging, for tagging, for object level logging. So these all are different properties that we are going to discuss step by step. And then we have the option of setting permissions. Now, remember, every object that we add in S3 bucket, they are private by default. That means as soon as we upload any object in S3 bucket, these objects are private by default until and unless we make them public. For example, if we upload any object to our S3 bucket, each and every object, they are going to be private. That means even though their URL is going to be generated, if we want to share them with the public, then means we have to make sure that we are making them public. Then only they will be allowed to have the access for the users coming from the internet. So by default, each and every object is private by default until unless we make them public. So if we want to give the public access to the bucket that we, for the objects that we have created, then we have to uncheck this option which says block all public access. When we uncheck this option, it doesn't mean that we are making all the objects public. It doesn't mean that we are making all the objects public. That means we will be allowed to make the objects public if we want to. We will be allowed to make the objects public if we want to. So here we can keep it to public for now. And now we can click on next. We can review all the parameters that we have configured. And now we can click on create bucket. So now we have the bucket created by the name of August 1, and that has been deployed in which region? In Mumbai. So once we open the bucket, we will be able to see this bucket is completely blank because we haven't added any objects to it yet. Now here we can start creating a complete folder structure, or we can add the objects directly. So for example, if we want to create the object, here we can click on create folder. Suppose we want to have a separate folder for images. We want to have a separate folder for PDFs. We want to have a separate folder for, suppose, for logs. Then either we can create multiple file structure as in the folder structure, and then we can start adding objects in this folder, or we can upload the objects directly in the root path itself. We can do that. And here we can click on upload. We can choose, now here we can drag and drop, or we can choose any object that we are going to upload here. So let's upload some of the static files that we already have the access to. Now these are the sample HTML files that we have the access to. Now, for example, if we choose alert and animation, we have background, we have a JPG as well, we have canvas, we have MP4 image, we have these many sample image, we can say sample files that we are going to upload. Suppose if we click on open, here we can choose all the files, click on next. Now, here we have the concept of classes. Now we are going to discuss on the concept of class as we proceed further step by step. But just to give you an overview, basically we have three classes available in S3. We have standard, which is basically used for those kind of files which are frequently used. Then we have infrequent access, commonly abbreviated as IA, which is used for those files which are not being used frequently to avoid cost. And then we have Glacier, which is basically used for storing archive files. Why we have these different classes? Because they all differ in terms of pricing as well. So based on requirement, how frequently we are using the file, we can place them in the right class to maintain a balance between the price and the performance. We can click on next, and now we can click on upload. So all the files that we have selected, these are going to be uploaded. So you can see all the files, all the objects have been uploaded, and for every object we get a metadata. For example, if you open a background of JPG, so we can see the owner, when it was it last modified, the e tag, the source class, and the object URL. That means this is a shareable URL link that we can have for the object that we are sharing. As we discussed, each and every object that is uploaded in our bucket, that is private by default until and unless we make it public for sharing. So we have to, so if we open up the object URL here, we can see this one will say access denied. Why? Because as we discussed, each and every object that we upload in our S3 bucket. So until unless we have a bucket policy defined, we'll be finding each and every object defined as private. And to make it shareable, we have to make sure that we are making the object we are making this selective object public. And once we make it public, then if we open the same URL, we will be able to open the URL in the browser that we can share with anyone. That means anyone with the given URL, they will be able to access the current object.
CloudFront service. So we have CloudFront. And remember, guys, CloudFront is not a part of free tier service. So CloudFront is something that we have to pay for. So as soon as we deploy CloudFront, that we have to pay for using that particular service. So here we can click on create distribution. We can choose web servers, and here we can define the origin domain name. That means which bucket we want now. We have a bucket deployed with the content, and now which content we are going to distribute in the edge locations. So we can choose the bucket that we want looking to distribute. So for example, here we have August 8. So here we can choose August 8. But before you can use this content delivery network, we have to make sure that if we are hosting a static website, we have to make sure we have the bucket policy also defined. So we haven't defined the bucket policy for it. Or let's do one thing. Let's choose the bucket for which we have the bucket policy already defined. That is August 5. So first of all, here we have to click on create distribution, the web servers. Here we can choose a bucket or any of the, for example, even if we have multiple load balancers, we can use the CloudFront service for deploying those kind of services as well. So here we can choose August 5, August 8, or any kind of services. For example, here we can choose CRR for August 5, August 5 CRR itself. And here, if you have a specific bucket, for example, if we want to deliver all the content under images folder.
So here we can choose the images folder in case we want the folder to be delivered only for the images itself. All right. So we want the entire content to be deployed, which is available in the root folder itself. So here we can keep it to just root folder itself. And here we can define, if you don't want to have any kind of restriction, then we can choose it to be yes or no, depending upon the requirement. And here we can define the entire cache behavior settings, as in for how long we want to retain the cache, and if we want to apply any kind of policies to it. So we are going to discuss about these policies in detail once we are done discussing the concept for VPC. And in here we have a distribution setting available where we can choose if we want to distribute globally, then we can use all edge locations. But if we have a requirement of deploying this website only for the North American market, then here we can choose only US, Canada, or even Europe as well. Or we can choose to deploy this in US, Canada, Europe, Asia, Middle East, and Africa. So that the entire CloudFront is going to be deployed on the edge location only in these regions, so that we can save a good amount of money, because we know, suppose if our end users are only in US, Canada, and Europe, not in Asia and not in any other part of the globe. So instead of using all the edge location, we can choose this one so that we can save a good amount of money here as well. And then we can, once we are done, we can click on create distribution, and this distribution is going to be deployed by using this current bucket. And once you open the distribution, now this is the domain name that we are going to get. So once this has been deployed, we can use this domain name and then we can map this domain name, for example, to our own website, or we get our own URL using any other domain routing service. so that once they enter the domain name in the browser, then this is going to be used as a distribution model. Now, for example, after creation of this entire distribution, now let's say we don't want this particular distribution to be available in some selective countries, then we can apply the restriction policies as well. So basically here we have a tab called restrictions, right? So under restrictions, we can choose which country we want to restrict the distribution in. So here we have geo restriction. We can click on edit. Yes. And here we can simply add the countries to blacklist or whitelist. For example, say here we don't want this content to be delivered to France. Now, no hard feelings for France. Suppose we don't want the content to be delivered in, suppose in Sri Lanka, then here we can add Sri Lanka. RDS. Let's open this up. Now here we can start creating a database. So here we have to click on create database, and here we can choose what kind of engine we want to create. So first of all, here we have two options with us. We can use a standard create or we can use easy create. So just like whenever we are trying to install any application on Windows, any software in Windows, we can choose we want to proceed with the custom installation or we want to proceed with standard installation. So in standard, we get to choose each and every configuration that we want. We can choose each and every parameter that we want to define for the current RDS instance. Or if we are defining this if we don't want to define the custom parameters, then we can choose easy create, and the instance is going to be deployed with default configurations. As you can see here, all the default configurations are going to be selected and the instance is going to be deployed accordingly. So if you want to have a complete control, then we can switch to standard create. Now, once we have chosen the configuration type, then here we have to choose the engine type. We can choose Aurora, we can choose MySQL, we can choose MariaDB or Postgre or Oracle database, depending upon the requirement. Now, suppose we want to start with MySQL, we can choose MySQL. Now, we don't get the MySQL Enterprise Edition. We get only the Community Edition available to us by AWS, and here we can choose version. We have support from 5.546 till 8.017. So that if we already have database stored in MySQL, which we are going to migrate, then we can choose exact correct version so that we don't get any kind of compatibility issues when we are trying to migrate data from one version to the other. So let's say we want to deploy 5.646, we can choose this one. And since this is community, so there is no licensing involved here. Let's say we want to work on Oracle. So here we can choose Oracle. So Oracle has 4 different versions available. We can deploy Enterprise Edition or we can use Standard Edition. So when we are deploying Standard and Enterprise, the licensing for these 2 different editions are not included. We have to bring our own license when we want to deploy these 2 different editions here. But if we want to deploy edition 1 and edition 2, then we can choose if we want to bring our own license or we want to include the license given to us by RDS itself. Now, if we are looking to use the license given to us by RDS, then the costing almost doubles up. So for example, if we use bring our own license, then for deploying one instance, we had to spend almost $300 on a monthly basis, right? But if we are going to deploy, and this is for North Virginia, suppose let's say if we choose to if you want to include the license by Oracle itself, then here the costing will become almost double. So here we have to spend almost $600 on a monthly basis on a basis of per instance. So here we can choose if we have the license available with us. If we have an enterprise license for Oracle, then we can use it, or we can use the option of license, which is already included as a package. So let's say we want to, the same thing is applicable for Microsoft SQL Server as well. So let's say here we can choose MySQL, and here we can move to templates. So we have 3 pre-configured templates available. We can go for production, development testing, or we can go for free tier. When we want to simply try this out, we are simply here to learn things here, then we can go for free tier account. Free tier will allow us to deploy this RDS instance on T2 micro instance that we can use up to 750 hours of usage on a monthly basis. And remember, these 750 hours is different than what we get for T2 micro for EC2. So we can have 750 hours deployed for EC2, and then 750 hours for RDS is calculated separately. So here we can choose development testing. If we know, okay, we are going to simply test the instance first before we can migrate our entire data set, then we can go for development testing. Now in feed here, we cannot choose the instance type. As we scroll down, we get the access to only T2 micro. Whereas in development testing, we can choose the configuration as per the requirement that we want. That means what kind of instance we want based on the capacity required. And for production, generally for production, we maintain a standby instance as well. In case a primary database fails, then the load should be shifted to a secondary, or we can say standby instance. And that means we have to pay for using that for keeping that particular standby instance also readily available. So if you want to keep ourselves in free tier, then we can choose free tier access, and then we can be specific on the identifier. So if we are going to create a complete cluster of database servers, then we can keep it to then we can keep them in the same name. For example, here we can keep them to database 1, and here we have to define the username and password. So here we can define a username as admin. We can define any password that you are looking to use. Now these credentials are the one that we are going to use when we are trying to connect to this RDS instance from any of the client. For example, here we can use a MySQL client to get connected, or we are going to use the workbench in order to get connected to this particular instance. We can do that. And then we have to choose database instance size. Since we have chosen T2 feature, we get the access to only T2 micro. And then we can get the access to storage. So we can choose we want an SSD based storage, or we can choose the provision IOPS. We can choose depending upon the requirement. And then in feed here, we get the access to 20 GB of storage. And if we are looking to increase this, now we get this storage auto scaling, and this is not horizontal, this is vertical scaling. That means we can initially start with 20, and if we want to scale it up, then we can increase the requirement to 1000 GB as well. That means we have started with 20, and now we are going to increase the entire usage to 1000 GB. That means if we are using this database for our customer-centric website, and our customers, they are continuously signing up and adding details into the database, so obviously our database size is going to be increased. That's natural. And whenever it is increased, again, we can simply define we want to continuously increase the database size from 20 to 30, 30 to 40, 40 to 50, and we can define a maximum value. That means beyond this, we will not allow the database size to be increased. And here we can scroll down to availability. So if we are going for a production environment, obviously we have to make sure that we are choosing a standby instance as well. So let's say if we switch to standby instance to production, we can choose production environment, and now we can choose, we have the option for creating a multi-AZ deployment. That means based on the budget, we can maintain a standby instance in another zone, so that if one instance is down, then still the users will be able to access data from the copy which has been deployed in another zone. So this is something that we get only in production, not in the free tier access. So here we can keep it a free tier, and then we can choose the authentication. Now here we can choose the connectivity, as in which VPC we want to deploy this. Now whenever we are creating any particular database instance, we have to choose in which particular network we want to deploy it, and not just say in which VPC, which subnet we want to deploy this in. So here we can expand this. So generally in multi-tier architecture, what we do, for example, here we can create our own VPC, and in VPC, we keep the web servers in the public subnet. So we keep all the web servers in the public subnet, and we keep the database instance and application servers in the private subnet, because we don't want to have any kind of public access given to these critical instances, right? So we can keep all the application servers and the database instance in the private subnet, so that we can restrict the access for internet for these different resources, where we can connect them to the NAT gateways if we want to apply some kind of software updates and patches. And here we can choose in which VPC we want to deploy this database in, and that too in which subnet. if we don't want to allow any public access. Now remember, if you're trying to use this instance for your practice, you have to keep it to yes, but practically we keep it to no because we don't want any kind of public IP to be generated, right? So, but again, if you want that, we should be able to connect to this database directly. For example, if you want to connect to this database through any MySQL client, or we are looking to get connected via, let's say, MySQL Workbench, then we can keep it to yes for the time period we are going to manipulate it, and then we can restore it back to no. But generally, we keep it to no itself when for real-time scenarios. And here we can choose security group. That means what kind of port we are going to give the access to. Remember, whatever port we choose, we have to make sure that we are using the given port. That means that whatever port we are going to choose, that should be allowing the port access, that should be allowing the IP address, then only we can start using them. Because if the security group doesn't have given the access to any specific IP through which we are going to get connected, then the connection is not going to be established to this particular instance. And then we can choose default database port. Default port is always 3306. If we want to configure it, for example, we want to keep it as 3309, then we can change this as per the requirement. But by default, it is 3306. And then we can choose what kind of authentication we want to define for the current account. We want to keep it to IAM or also for just the password authentication that we have entered in our admin section. We can define the access type, and then we can define the additional configuration where we can define the backups as well. So in additional configuration, we can define how exactly the backup has to be retained for this database. So we are using a fully managed service. We are using a fully managed database service. That means here we can define when we want the backups to be taken automatically. Suppose here we can define the backup retention period as in, now we can define the backup retention period from 0 days to 35 days. Now when we say backup retention period, let's see what exactly we mean here. Let's say a backup has been taken up on August 16. And here we have defined the retention period to be 7 days. That means this backup is going to be retained till 23rd of August, right? And suppose now, if we define the backup to be taken on a daily basis, so tomorrow also a backup is going to be created. That means on 17th of August, and this is going to be retained till 24th of August. Same way, we can have all the backups defined. That means on 23rd of August, suppose if we want to restore the backup to any of the previous data set, then we can choose which database we want to use for restoration. And after 23rd of August, this database is going to be deleted because you don't want to create a pile. After 7 days, after max to max up to 35 days, we can retain the automated backups. Yes, we can create a snapshot and then we can retain it for a longer period of time. We can do that. But the automated backups, we can define for how long we want to retain them. So here we can choose any of the retention period we want. And then we can use CloudWatch for monitoring the entire resource here as per the requirement. And then we can export all the logs, like we can export the audit log, the error log, general log, and slow query log, depending upon the database engine that we have chosen. And then if you want all the minor upgrades to be updated automatically, then we can choose it. Or if you want all the updates, software updates, patching up the servers, that should happen in a defined window. For example, here we want to define a maintenance window because that is what it is done in majority of the real-time use cases. So here we can define it to be on a specific date itself, and then we can have the entire database instance, or we can say all the software updates and backing up the servers will be done in that timeline itself as per the window that we are going to define. Suppose we know that majority of the database is updated by the content team. Mostly of the updates are done by 9 p.m. From 9 to 11, we have the window open. So here we can define the database should be updated only after 9 o'clock, depending upon the requirement. So for free tier, we don't have to pay any licensing fee. We get free 750 hours of usage, 20 GB of storage, and 20 GB for automated backups. So once we are done, we can click on create database. And database creation almost takes more than 7 to 8 minutes. because the entire instance is going to be deployed. The entire whatever database engine we have chosen, that is also going to be installed and configured, and also all the entire OS, all the licensing also has to be configured. So generally it takes up to 7 to 8 minutes for the entire instance to be deployed here. Now, once the entire instance has been deployed, we will be able to see an endpoint being generated. So in order to connect to this instance, we can use those endpoints, and then we have to specify the port as well. So we can use any of the client that we want to use for getting connected. So either we can connect directly with the MySQL client, or we can use application that we have hired SQL. We can use MySQL Workbench, which are basically GUI based tool. So we can get connected to these different databases by using those GUI tools itself. We can do that. At the end, when we create the endpoint, this is how the endpoint is going to look like, and then we have to enter this endpoint in the application. We can say we can enter this endpoint to any of the MySQL clients we have, or we can use Workbench to get connected as well. We can do both. Now we can go back to our dashboard. Now here we can open up a service called as Lambda. Now as a part of a hands-on, let's say we want to create a Lambda function, and then using this Lambda function, we want to get notified whenever any object is being added to S3, we want to get notified. So what we can do for doing this, we can create a Lambda function, and then we can link this with the bucket. That means whenever that bucket operation is triggered, for example, whenever any object is deleted or is added, then that is going to trigger the Lambda function, and then we can define whatever function we want to execute, we can define that. For example, whenever any end user uploads any object to this S3 bucket, so we want that whenever this object is being added, this should trigger an event, and this should simply trigger the execution of a Lambda function that we have created. Now we can create the function in any language. For example, here we can create the function for in Node.js, in PHP, in Java, whichever platform we want it to be created. And then suppose if we are going to create a function in Node.js which is going to send an email to whichever email address we have specified as a part of Lambda hands-on. So let's do that. Let's delete this previous function so that we can start from scratch. Actions, delete. Now, when we are creating a function, we can start to build a function from scratch, or we can use any of the blueprint. We can use any of the blueprint that we want to use, or we can browse the serverless app repository as well, basically like a multiple application which has already been deployed in Lambda service. We can make use of any of these previous applications as well. Now, let's say we author from scratch. So we can give this function a name, as suppose we can name it as Lambda itself. And when we are building a function, obviously the function has to be deployed in a runtime. So here we can choose which runtime we want to deploy the function in. We are going to create a .NET function, a function for Java 8, for Node.js, for Python, on Ruby, on .NET, on Go languages, or on .NET Core as well. So we can choose any of this runtime for which the function has to be deployed. Let's say we want to choose Node.js environment. Here we can choose Node.js. And then if you want to add any permission, for example, we want to add any role to it, then here we can add the role as well. And once we are done, we can click on create function. Now in here, we can start defining the function here. We can start defining the function as per the requirement. So first of all, here we can scroll down. So here, now in this screen, we have to create the entire function. In here, we have to create the entire function. So for example, here, let's use one of the function that we have already created. So let's fetch the code just a moment. So now this is a sample function that we have created on top of Node.js. So when we are using this function, for example, here we have defined the entire SDK. Now here we are going to use the AWS SDK, and for sending the email, we are going to use the SCS service here. And in here, we have defined the region as AP South 1. So currently here we have to make sure that in whichever region we are going to create this function, the region name has to be the same. For example, if you're trying to deploy the same thing in North Virginia, then this has to be US East 1 as per the setup that we have defined. All right. Now here we can define the entire text body of the message. For example, here we are going to invoke the email function. So here we can define what kind of email we want to send to the end users. We can define the entire content for body and for subject line as well. So if you want that, okay, this kind of email should be sent where the body should be containing a message such as an object has been added to S3 bucket. And in here, in terms of data, that is the subject, should be this one. And then we can here we define the entire function for sending the email parameters by using the SEO service. So once we are done, we can save the function here. And if you want to test the function before actually integrating it, because same thing that we do for multiple web applications as well, we have something called as Selenium. For example, just like we use Selenium for writing the test scripts for multiple applications. So here we can use the test events. So here we can click on configure test events, where we can create our own test event, or we can choose from the templates as well. For example, here we can choose from here. The main purpose of building this function is to get the notifications for any of the events being triggered for S3. For example, S3 put means whenever any object is going to be added, here we can choose put, and here we can see the entire script has already been defined that we can make use of. For example, here we can see the entire object here, the bucket, that means from which particular AMI, which particular bucket we want to test here. For example, here we have the example buckets, or any of the bucket parameter that we can define here that is going to be tested. As in the E tag, the size, that means what kind of object is going to be added here, we can test it out. Let's say we define it, the event as S3 object put test. We can define the name, click on create. Now, if you want to use this event for testing this entire function, then here we can click on test, and this is going to run the entire test, for which we can see the output as well. So if we scroll up, we would be able to see the output. The entire test took 100 milliseconds to be deployed, and then the resource use was, and this is the output that has been given to us. Now, when we are working on Lambda, we can define the configuration as well. Suppose if we scroll down, here we have something called as basic settings. Here we can allocate a memory to this entire function from a range of 128 MB till 3008 MB. Maximum we can allocate up to 3008 MB for this entire function. We can choose a runtime. That means this has to be executed in which runtime, depending upon the requirement. And then we can assign the rule as per the requirement that we have. And as a part of limitation for Lambda, a single package of whatever function we are going to create here. For example, suppose if we would have chosen any other package, for example, here instead of Node.js, we had chosen suppose Java package. Then a single package, a single deployment package that we want to be executed in Lambda, it cannot be bigger than 250 MB in size. And in a given region, we can add up to 75 GB of packages, not more than that. That's a limitation that we have in Lambda. A single package could not be more than 250 MB in size, and the maximum execution period that we can have for Lambda is going to be 15 minutes, as in 900 seconds. That's a maximum continuous execution time that we can achieve for Lambda for using Lambda service. 15 minutes. Again, these all are soft limits. If you want these limits to be uplifted, we can contact support, and then we can have these limits increase as well if we do have a requirement. So once we are done, we can click on cancel. Now, once we're done testing the entire event, we can click on save. So now this function has been saved. Now the main purpose of this function is to get the updates for any of the events happening for the S3 bucket, right? So now we have to link this with the S3 bucket, for which when we want to trigger this Lambda function. So we can come back to service. In service, we can look for S3. Here we can, suppose if we want to work with this one, August 18, we can open this up. Here we can, now here for linking the Lambda function to multiple events, we have to go to properties. Under properties, we have to scroll down, and here we have something called as events. So now here we have events. Here we can click on add notification. We can name this as Lambda service, and here we can choose event type as put. We can choose a prefix, the suffix that we want to use for this entire function, and here we can click on send to. So suppose if you want this to be sent Lambda function, okay, we have to make sure that we are using the bucket that is in the same region as a function. So this bucket is in the same region as a function because we have the function deployed in Mumbai. So you can open this bucket, go to properties, events. We can add event. Let's name it as Lambda. Now we want this event should be triggered for the put action. So here we can choose put. We can add any prefix for if you want this event should be triggered only specific set of folders and for specific set of files, then we can be specific for that. And here we want to send this to Lambda and to this function that we have created. So if you save it, now here we are linking this to an event. That means as soon as the put event is triggered, we would be getting notifications for it. Let's do one thing. Let's add any object here. We can click on upload. We can choose to upload any object because again, at the end, we are only going to trigger the put function. So let's choose any of the objects. Suppose we have this home file, we can click on next. We can choose any class. Here we can click on upload. And now we have this home.html currently uploaded. That means now this is going to trigger a notification. And if we come back to our inbox, then this should be sending us the notification in a minute. Okay, we haven't received the notification yet. Why? Because there must be some misconfiguration done in the Lambda function. So let's go ahead and test it out. Where exactly we have, what kind of parameter we have missed. So if you come back to Lambda, let's open up this function. Okay, this event was triggered, but again, we haven't defined the to address and from address. So obviously this is not going to send the notification to anyone, right? So here we have defined the email address. So let's enter the email address here for to and from which email. That is also something that has to be defined. So we can define the email. Now we can save the function. And now let's say we come back and do the same change in S3. Now we are going to receive the notification. Let's say we open the bucket. Here we have defined the event, right? So now if we come back to the bucket, here we can click on upload. Here we can choose add files. Let's suppose we add simple PPK file as per the private key. This object has been uploaded. That means the event would have been triggered and now we would be receiving the notification. As you can see, now this Lambda function has been triggered and now the same email that we have structured as a part of a function has been sent to us just now.
The first domain in AWS services is AWS Compute domain. So let's discuss the services under compute. So the first service is EC2. So EC2 is the most important service in the whole of the compute domain. So why do I say it's the most important service? Because EC2 is the base and the other services which are Lambda and Elastic Beanstalk are just advanced version of EC2. How? Let's discuss that. So EC2 is, like I said before, is just like a raw server. Now you can configure this raw server to be anything, right? You can configure it to be a web server, like I said, or a worker tier environment or something else. Now, and this web server can be resized according to your needs. The instances or the servers that you've launched, they can be replicated, as in you can launch multiple servers of the same configuration, or you can also increase the configuration as well, right? So this is the kind of resizability that you get with EC2, and this is what EC2 is all about. So the first service in the computing domain is EC2. So EC2, like I said, is just like a raw server. You can configure EC2 service to be anything. So it can be configured to become a web server. It can be configured to become a worker tier environment. The softwares that you require can be installed and the server can be configured in any way required, right? And that is the kind of independence you get that when you're using EC2. But what is the difference? You can resize the server as and when required. It can be resized according to the number of servers that you're using, as in if you're using, say, suppose a particular configuration and you want to deploy the same configuration again and you want to host or you want to serve your application through these number of servers, you can do that. or otherwise you can also increase your configuration on your particular instance. Now the way to understand this is, say suppose you're using the i3 configuration right now, you're using the i3 processor on AWS and you want to go on to i5. You can do that. You can do that kind of resizability as well. So this is the kind of flexibility you get when you're using EC2. So let's move on to our second service now, which is AWS Lambda. So AWS Lambda, like I said, is an advanced version of EC2. So it's based on EC2, but the difference between EC2 and Lambda is Lambda cannot be used to host your application. Lambda can be used only to execute your background tasks. Now, what are your background tasks? Say suppose you have an application, right? And your application is all about images. So when you upload an image, that image is compressed and it is stored on a file system, right? So your image will first be uploaded to the file system, right? So when the image is uploaded, that is performed by our application. Now the tasks which have to be done in the background, like the compression, or maybe you have some more tasks like applying filters and everything, these tasks are background tasks. And these tasks can be executed using AWS Lambda. Now, how does AWS Lambda functions is like this. AWS responds to events. So there are triggers that you set up in AWS Lambda, and in response to these triggers, AWS executes the code, right? So in this case, in our example that we took, that we are uploading a file, right, or uploading an image. So the moment that image gets uploaded to, say suppose S3, which is the file system for AWS, a trigger is generated and that trigger is being listened by AWS Lambda. So when that event is listened by AWS Lambda, it responds to that event using the code that you provide. It executes that code and then sits again and waits for another event to happen, right? Now that code would include your code for compression, applying filters, etc. And that is how AWS Lambda functions. All right, guys, let's move to our next service now. So our next service is Elastic Beanstalk. Elastic Beanstalk is again an advanced version of EC2. But with this, the difference between Lambda and EC2 and Elastic Beanstalk is that first of all, Elastic Beanstalk is used to host an application. So if you compare it with AWS Lambda, this is the difference. Elastic Beanstalk is used to host an application. Lambda is not used to host an application. So this is the difference between Lambda and Elastic Beanstalk. Now let's talk about EC2 and Elastic Beanstalk. So Elastic Beanstalk is an automated form of your EC2. How? With Elastic Beanstalk, you don't have to configure in all the details, you don't have to set up your environment. Say suppose you have a PHP website that you want to host on EC2. Now for your PHP website to be hosted, you first have to create a PHP environment in your EC2, right? But with Elastic Beanstalk, you don't have to do that. You just have to select what kind of environment you want, and AWS will install all the configuration files required and will give you the environment on which you just have to upload your code, and your application or your website will be deployed, right? So this is how simple Elastic Beanstalk is. You create your environment and then you upload your code. That is it. Nothing else is required. So as you can see in the diagram, say suppose you have a PHP code. So you create a PHP environment first, launch it. Once that environment is created, you upload the PHP code and your application is deployed. As simple as that. So let's discuss what is Elastic Load Balancer. So Elastic Load Balancer basically is used to distribute your workload among a number of instances, right? Now the traffic which will be coming on these instances has to be distributed equally among these 5 or 6 instances, right? And this is what Elastic Load Balancer does. Now why is this important? Say suppose you have 4 or 5 servers running and all your traffic is directed to your first instance, right? So it doesn't make sense because all your other 4 servers are idle. You have the capacity with you, but you have not installed a protocol using which the traffic can be distributed to these 5 instances. And that protocol is Elastic Load Balancer. So Elastic Load Balancer distributes the workload equally among the instances so that the work is done efficiently, and also the work is consistent. As in, if I am using, say suppose, a website which is being hosted on AWS, I should experience the same kind of response time as you are experiencing using the same website, right? Say suppose my request is going to the fifth server, which is less busy, and your request is going to, say, the first server, which is more busy. In that case, your response time and my response time would become different. That is why we use elastic load balancer. So if I am using your website and you are using the same website, you and me will experience the same kind of response time because it's being distributed equally among the instances, and the instances are busy on the same level. So this is what elastic load balancer is all about. All right. Let's move on to our next service, which is auto scaling. So auto scaling is a service which is used to scale up and down automatically without your manual intervention. Now, how do you do that? You set up metrics. Now, say suppose you have a website running and that website is running on 5 servers. Okay, and you configure a metric that whenever combined CPU usage goes beyond 70%, launch a new server, right? So whenever your CPU usage will go beyond 70%, it will launch a new server, and then focus guys, and then the traffic will be distributed among the 6 instances, right? So I said distributed, so this work is done by elastic load balancer, and that is why auto scaling and elastic load balancer go hand in hand. They have to be used together. So if you're using auto scaling, you have to use load balancer as well, right? And like I said, you can scale up using that metric, and you can also set a metric for scaling down. Say suppose your combined CPU usage goes below 50% or goes below 10%. So you can configure your auto scaling to decommission a server in that case, and hence you can scale down from the number of instances that you're running. And again, your workload will now be distributed to, if you had 5 servers before, it will now be distributed to 4 servers, which again incorporates elastic load balancer. So like I said, auto scaling and elastic load balancer have to be used together. Let's move ahead. Before moving ahead, let's make it interesting. We have studied a lot of theory. Let me deploy a new EC2 instance for you guys. So let's go ahead and deploy a new EC2 instance. So I'll go on to my AWS console and sign in. So this is how your AWS dashboard looks like. These are all your services, right? So since we have to deploy a new EC2 server, we'll be clicking on EC2, which you can find under the compute domain. So let's click on EC2. Now this is the EC2 dashboard. Over here you can monitor your EC2 instances. As you can see, I have 2 running instances as of now, and I have 4 snapshots, 4 volumes, and 51 key pairs. Right, so you can monitor your EC2 services from over here. Since we are launching a new instance, we'll click on Launch Instance. Alright, now you have to choose an AMI. So AMI is nothing but an operating system that you would use to, that you would want on your EC2 server, right? For now, let's launch a Windows server. So let's click on Windows. Now you will be asked for the kind of instance that you have to select. Alright, you don't have to worry about the instances as of now. You can select the t2.micro. And don't worry, because we'll be discussing everything in detail as we move ahead in our journey, and when we come down to the EC2 module, we'll be learning all about these different instances. So for now, just click on t2.micro and click on next. Now it's asking me how many instances do I want. Okay, since it's a demo option, since it's a demo, I'll launch only 1 instance. And then it's asking me the networking settings and everything. Okay guys, don't worry, everything will be discussed in detail in the EC2 module. For now, let's just focus on deploying this instance and click on next. Ignore if you don't understand, I will explain everything to you guys. Alright guys, now we come on to add storage. So with Windows, by default, you have to launch with a minimum of 30 GB. You can also expand it over here as per your requirement. So I'm okay with 30 GB. Let's click on next. So now we have to add tags. So what do you want your instance to be named, right? So you can give your name over here. So the key is name, the value could be a Windows server, right? Let's click on configuring security group. All right, a security group is basically like a firewall on your instance. It is used to control the inbound and the outbound traffic which comes on your server. So how to do that? We'll do that in the modules that'll be coming in the coming weeks. For now, just understand what security group is all about. So it is used to control the inbound and outbound traffic. If you don't understand that as well, it is okay. We'll just click on review and launch. So we'll review all the settings which we have just done. Everything looks fine to me. Let's click on launch. Alright, this is a very important step. Now the way you get authenticated to your instance is with a private key and a public key configuration. So it's called a key pair. So basically you can create a new key pair as in a new public key and a private key, or you can use an existing one. So the public key is kept with AWS and the private key you can download, and whenever you want to connect to your instance, you'll be using the private key. You'll be uploading a private key to the console that you have for launching your instance, and that private key will be matched against the public key, and you will be given a password, and using that password you can connect to your instance. Right? So whenever you're creating a new key pair, you have to keep your private file handy and you have to keep it safe, because once you lose it, you cannot connect to your data is gone. Right? So you have to be very careful with your private keys. So for now, let me create a new key pair for you guys. So let's click on create a new key pair and give it a name, say AWS demo. Right? So let's download our private file. Alright, it says that AWS demo already exists. Okay, let me give it AWS demo 1 and click on download key pair. Alright, my private file has now been downloaded. Cool. Let's now launch my instance. So my instance is now launching. Meanwhile, let's go back to the EC2 dashboard and check if you can see if our instance is being listed there. So we'll go to EC2. So as you can see, we had 2 running instances before, but now we have 3. So since we have launched a new EC2 server, we can see 3 running instances, right? So let's click on it and it will list you all the services which are running. So we named our instance to be Windows Server, so here it is. The instance type is t2.micro. You can also look at the key pair that we have launched it in, so it's called AWS Demo 1. You can see the timestamp here and you can see the security group here. So once you click on your instance or once you select your instance, you can see all the details attached to your instance. Say suppose the public IP. So this is the IP that you'll be using to connect to your instance. So your instance type, your instance ID, the VPC, subnet, everything can be monitored over here. So the way we'll be connecting with this Windows instance is using a remote desktop connection. So once you open your remote desktop connection, it will ask you for an IP address, right? So that IP address has to be copied from here. So this is your IP address that you'll be copying. So once you copy this IP address, it will ask you for the username and the password. So by default, Windows uses a username called administrator, and for the password, you have to upload your PEM file, which is over here on your launch console, and it will decrypt a password for you by matching the private key with the public key, which is there with AWS, and then using that password, you can connect to your Windows instance. Sounds simple, right? So let's do it. It's still initializing. Let's wait for it to initialize and then we'll start with our demo. So our Windows server is now running. We can see that it says green over here and it says running. Alright guys, let's launch or connect to our instance now. So you'll be clicking on actions and you'll be clicking on connect, right? Then you'll be prompted on for the screen and then you'll click on get password. Once you do that, you'll be asked for a key pair path. Let's choose our key pair now. So we'll go to desktop and we'll choose the key pair, which is AWS Demo 1. We'll click on open and we'll click on decrypt password. So I can see the password here now and I can see the username, right? Let's now connect to our instance. So let's copy the password to somewhere. So this is our IP address. So like I said, we will copy this IP address and we will launch the remote desktop connection. So it's asking me the IP address. I will paste the IP address over here and click on connect. So it's asking me for my credentials. So since my username is administrator, and then I will copy the password that I decrypted. Let's click on OK. So as you can see, it's now connecting to my server, which I've launched on the AWS infrastructure. And this is it. So this is your desktop, guys. This is the server that you launched on AWS infrastructure. So just like a fresh operating system, you can click on start. You can see the way you would see it on your machine. Now you can install any software over here and you can configure this server to be anything. Pretty cool, right? So guys, this is what EC2 is all about. This is how you connect to your EC2 server once you launch it. Alright guys, let's come back to our slide. So we just learned how to launch an EC2 server on AWS infrastructure. We learned how to connect to a Windows instance on AWS. Let's move on to our second domain, which is AWS storage domain. All right, so let's discuss services in the storage domain. So first up, we have these S3, which is simple storage service. So S3 is a file system. So it's an object-oriented file system, which basically means that all your files that you upload on S3 are treated as objects, right? And these objects have to be stored in a bucket. Now, what do you mean by a bucket is you can consider the bucket to be a folder. So the root folder has to be a bucket, right? You cannot just upload files onto S3. You have to first create a bucket. Inside this bucket, the secondary folders are called folders as in the normal lingo. But the first folder, the folder in the root, is called the bucket. Now, once you create a bucket, it's very simple. You can upload your files, and these files in the AWS lingo are objects. Alright, so you can upload your objects and these objects will have a certain path which you can incorporate in your application, and that is how you can access your file from your file system. So this is what S3 is all about, pretty simple. Next, move on to our next service, which is CloudFront. So CloudFront is that content delivery network that I explained to you guys. So it's a caching service, like I said. So as you can see in the diagram, if a user wants to connect to a website which is very far from the user's location, that website can be cached to a location which is near the user, and from that location the user can access that website. Now, why would you do this? Is because the response time becomes less in this case. So say suppose if you were using that website from that far off server, you were getting a latency, say suppose around 0.7 seconds or 0.8 seconds. Now with this caching, you can get the same website for around 0.2 seconds or 0.3 seconds. Now this is very huge when you compare it at a global level. And that is what content delivery networks are all about. So our next service is Elastic Block Storage. So Elastic Block Storage is basically like a hard drive to EC2. So when you're using EC2 instances, obviously your operating system or your software is being stored somewhere, right? So EC2 is backed by EBS for that matter. So EBS basically acts as a hard drive for EC2 and it cannot be used independently. It has to be used with EC2 only. Another interesting fact about EBS volumes is that one EC2 instance can be connected to multiple EBS volumes. But the vice versa is not true. One EBS volume cannot be connected to n number of EC2 instances or more than one EC2 instances. Each EBS volume can be connected to only one EC2 instance. And why is that? Is because you can imagine it like this. So if you have one hard drive and at one time that hard drive can be only be connected to one computer or one motherboard, right? You cannot connect that same hard drive to 2 or 3 motherboards, correct? And that is the same case with EBS as well. So it's pretty logical when you think it like that. Let's go ahead. Let's move on to our next service, which is Amazon Glacier. So Amazon Glacier is a data archiving service. So basically when you have to back up data from your, say suppose S3 or your EC2 instance, you back it up on Amazon Glacier. So why would you back it up on Amazon Glacier is because they use magnetic tapes and these magnetic tapes are cheap and hence your data storage on Amazon Glacier becomes cheaper, right? Now, why would you store on Amazon Glacier or which data would you store on Amazon Glacier? So you would store data which is not that frequently accessed. Your use case could be something like a hospital, wherein you have to store test records of all your patients, right? But what about the test records which are more than 6 months old? those patients are not returning, right? So you can store that data on Amazon Glacier, and if tomorrow, maybe in some time when that patient returns, it can always be retrieved from Amazon Glacier. Obviously, since it's cheaper, the retrieval time will be more if you compare it with S3 or with EC2, but then it's worth it because it's cheaper. So this is how you would use Amazon Glacier. Let's move on to our next service, which is Snowball. So Snowball is basically a physical device which is used to transfer data from your data centers to the AWS infrastructure. Now say suppose you have an application and you decide to make a move to the cloud, right? You're hosting your application on your own for now, but now you have decided, okay, I want my application to be on the AWS infrastructure, right? Now your application is already running. It is very successful. It has a huge data set that is being served by your servers on your own data center. Now this data set has to be migrated to the AWS infrastructure, right? Now the way you can do it is in two ways. You can either transfer it online or using the internet. You can do the transfer using a physical device, right? Now this physical device is Snowball. So when will you use Snowball and when not the internet is when you'll have huge amount of files, right? When you have say data at a petabyte scale, in that case you would use Snowball to transfer your data, right? Now how this process happens is like this. AWS, when you have to request for a Snowball device, right? So that Snowball device will come to your premises. You transfer the data onto that Snowball device, and then that Snowball device is shipped back to the AWS infrastructure where the AWS experts will upload your data to their own data centers. Right? Now, if you were to use internet for a petabyte scale of transfer, it would take a lot of time. But with Snowball, all of this can happen within 10 days. So you're saving costs on your internet, you're saving your bandwidth, and your process is happening faster. So this is how Snowball comes in handy. Let's move on to our next service, which is Storage Gateway. So Storage Gateway is a service which is used between your data center and your cloud, or it can be used between your data center's resources as well. Now how is it used is like this. Say suppose you have database servers and you have application servers, right? Now your Storage Gateway, what will sit in between your database servers and your application servers, and it will keep on taking snapshots of your database and will keep on storing it on S3. Now, if you have, say, suppose 3 or 4 database servers and you have Storage Gateway installed, and your fourth database server gets corrupted because of some reason. Now, what Storage Gateway would do is it will recognize that a failure has happened. It will take the related snapshot or the respective snapshot and restore your server in which the snapshot was taken. And that is how Storage Gateway works. This was about your private resources when you're using your own database server and your application server. The same can be done in AWS infrastructure as well when you're using EC2 and RDS, which is a database service. So Storage Gateway can sit in between these two services and can serve the same purpose. So this is what Storage Gateway is all about. So let's move on to our next domain, which is the AWS database domain, right? So the database domain would include all of these services. So the first service in the database domain is RDS, which is a relational database management service. So the thing here to understand is that RDS is not a database, it's a database management service. So it manages databases for you. Now, which database does it manage? It manages relational databases for you, right? So it manages databases like MySQL, it manages data like Oracle, MariaDB, PostgreSQL, Microsoft SQL Server, or Amazon Aurora, right? Now, what are the management tasks that we are talking about? So it updates the DB engines automatically. It installs the security patches automatically. So everything that had to be done manually or will be done manually if you're hosting a database server, it does that automatically for you. And that's why it is called a management service, right? So this is RDS. Now, the difference between RDS and a service that we'll be discussing sometime later, that is DynamoDB, is that they both are management services, but RDS is for relational databases and DynamoDB is a non-relational database. So what we'll see that in detail later. So let's move on to our next segment, which is Amazon Aurora. So Amazon Aurora is a database which has been developed by Amazon itself. So it is included in RDS, that is, it is a relational database which is also managed by RDS. But what is the difference between Amazon Aurora and NEC and the other databases which are already out there? is this. So Amazon Aurora is actually based on MySQL. It means that the code that you're using with MySQL will work with Amazon Aurora as well. But then Amazon claims that Amazon Aurora is 5 times more faster than MySQL. So if you are using MySQL and you replace your MySQL server with an Amazon Aurora server, you will experience 5 times boost in your performance. And this is what Amazon claims, and that is what Amazon Aurora is all about. So if you're using Amazon Aurora and you were using MySQL before, you don't have to change your code because it will work exactly the same with the code as it was you working with MySQL, because there's no change in the code when you talk about MySQL and Amazon Aurora, but you will get that performance boost when you're using Amazon Aurora. So our next service is DynamoDB. So like I said, DynamoDB is also a management service, but it manages non-relational databases for you. So when I say non-relational databases, I mean NoSQL databases. So if you have unstructured data that has to be stored in a database, so where will you store it? You cannot store it in a relational database. You have to store it in a non-relational database. And the non-relational databases are managed by DynamoDB, right? So DynamoDB is actually a NoSQL database which also gets managed automatically. All right. So when I say managed, it gets updated. The security patches are installed automatically. Everything is done by DynamoDB itself. There is no manual intervention required. Also, the thing with DynamoDB is that you don't have to specify the amount of space that you will be needing. The moment more data comes in, the database automatically scales, right? So it grows automatically. Your manual intervention is not required. If the storage is coming low, nothing is required in DynamoDB. You just go to the DynamoDB console and you start creating new tables. It doesn't ask you for anything. You don't have to configure any storage property or anything like that. It grows automatically and shrinks automatically as well. So this is about DynamoDB, guys. Alright, the next service in the database domain is DynamoDB. So like I said, RDS is a database management service for relational databases, right? DynamoDB is a database management service for non-relational databases. So when you have unstructured data, you store your unstructured data in a non-relational database. You cannot store your unstructured data in a relational database, because relational databases consist of the data that can be structured in a table. But when we talk about unstructured data, we say, suppose, let's talk about something random. Let's talk about your posts on Facebook. They're all random, right? So if you have to analyze your posts on Facebook, you just have to take that data and you feed it into a non-relational database, and it makes sense out of it. This is the power of a non-relational database, and DynamoDB is a non-relational database management service. So it's a service which manages a non-relational database for you. The other thing with DynamoDB is that you don't have to specify the storage space that you'd be needing. As and when the storage requirements increase, your database scales automatically. So if you have a storage requirement of 10 GB today, and tomorrow you'd feed in data of say 5 GB more, so your database will grow automatically and you'll be charged according to that. If you're using 15 GB, you'll be charged for 15 GB and so forth. So you don't have to manually intervene to increase your storage. DynamoDB does that automatically. So this is about DynamoDB, guys. Let's move on to our next service, which is Elastic Cache. So Elastic Cache is a caching service. So it is used to set up, manage, and scale a distribute environment in the cloud. What that basically means is, say suppose you have an application, right? Now the way databases works is like this. You query something from database, the database processes that query and in turn gives you a result. But what if there's a lot of demand for a specific kind of result set? The same query is running again and again and again, so it increases the overhead on your database in getting the same results again. So with Elastic Cache, what you can do is, as you can see in the diagram, the user was first accessing this query from database, but now since it has analyzed that this query is being asked very frequently, it stores the result set in Elastic Cache, and whenever that query comes in, it directly feeds in that result. So the DB's overhead or the database's overhead is reduced because the request never reaches database, because it has already been processed and it is stored in Elastic Cache, and the Elastic Cache in turn serves the user with the result, and hence this process becomes faster. And this is what Elastic Cache is all about. Alright guys, let's move on to one last service in the database domain, which is Redshift. So Redshift is a data warehouse service. So it's a petabyte scale data warehouse service. So it gets data feeded from RDS, it gets data feeded from DynamoDB, and it does analysis on it. So it's an analysis tool. It's a data warehouse service which can be used to analysis on the data that you have stored on your database, say like RDS or DynamoDB. Alright, so it's an analytics tool. It's a data warehouse service, like I said, which is used to analyze data, and you can feed the data from RDS and DynamoDB as well. So this is we end the database service on Redshift. Let us now launch an RDS service. So let's go back to our AWS Management Console. Let's go to the dashboard for AWS. So under the database domain, we can find RDS over here. We'll click on RDS. Alright, we'll click on instances. So there are no instances as of now. So let's launch a DB instance. So we have to select which database do we want to be managed, right? If I say, suppose I want to manage MySQL, or I want my application or my database is, say, suppose hosted on a MySQL server on my local host, right? If I want it to be migrated to AWS infrastructure, I would want the same database over there as well, right? So I will choose MySQL over here and click on select. Now it will ask me which environment do I want it to launch in. So there are two kind of environments. One is the prod environment and the other is Devo test. That is the development or the test environment. Since ours is a demo, so we'll launch it in a test environment and click on next. So over here we'll be configuring our instance. So it'll ask me for DB instance class. Let's select the minimum, which is db.t2.micro. So we'll be discussing all of these instance types when we reach the database module. So don't worry about it. Just go with the flow. Select db.t2.micro, and then it is asking me for multi-availability zones deployment. So multi-availability zones deployment is something related to availability. So if you want your database to be there in different availability zones, so that if one availability zone goes down, the other is there, you would choose yes as an option over here. But since ours is a demo, we'll select no. And it is asking for the storage type. So it is SSD, provisioned IOPS, magnetic. So basically the options here is given according to the use case. So if you have an application, if you want low latency, so you would choose accordingly, and we would discuss all of these in the database domain. So don't worry, just let us click at default for now, and let's go in the settings. So it is asking me how will your database be identified. So let's give it the name as Edureka demo. All right. Let's give the master username as Edureka, master password as Edureka123, and let's confirm the password again. Alright guys, let's click on the next step now. So it is now asking me for a VPC. Now guys, this is a step which is really important. If you have an application that you want to deploy in AWS and you want that application to interact with the database section as well, you have to include both these services. Say suppose you host an application on EC2. Now EC2 and your RDS or whatever service you're using for your database has to be included in the same VPC so that they can interact. So this has to be kept in mind when you are trying to deploy an application on the AWS infrastructure. So let us keep it at default for now. So I have a VPC called 82A742E5. So let's keep it at that. And it's asking me if VPC security group. So let's select the default security group. DB name, let's leave it blank. We'll launch our own DB, or we'll create our own DB. Okay, so over here you can select which version do you want. So it's 5.6. Everything else looks fine. You don't have to change anything here because we have not studied anything of this yet. So once we do that, I will explain you guys all of this, right? Let's click on launch DB now, launch DB instance. So it says my DB instance is being created. It will take a while for my DB instance to be launched. Let's see if we have our instance listed in our RDS dashboard. Alright, so my instance is being created now. So it'll take a while. Let's look at the other things over here. So once you click here, you will see all the data associated with your RDS instance. Now the way you will connect to your RDS instance is using your command line, right? So using a command line, you will use a command called MySQL. So for using that command, you first have to go to the bin directory of your MySQL installation. So yes, you should have MySQL installed on your local server from which you were trying to connect to your RDS instance. So you will enter the command MySQL once you are in the bin directory in your command prompt, and space -h. So H is your host name, right? And host name is nothing but your endpoint. I will show you guys exactly what to do, but since it's being created, I'm explaining you guys the process. So the endpoint is basically the host name that you will get. So you will get that once this is created, right? So when I say MySQL space -h followed by the endpoint, space hyphen capital P, which is the port number using which you will connect to RDS. So you have to mention the port number that will also be mentioned in the endpoint, and then you have to enter the username. So if you guys remember, I entered the username as Edureka, and it will be followed by hyphen small p, which is just the password. I'll click on enter. The next line, it will ask you for the password, and you will enter the password that you have specified while launching your instance. In our case, it was Edureka123. So we will enter Edureka123 over there and then hit enter, and if everything goes fine, we should be able to connect to our RDS instance. So guys, this is the whole process. In a few minutes, I will explain you guys how we will be doing that. Let's wait for we are just waiting for a DB instance to be created. So let's wait a little longer. Alright guys, our RDS instance is launched. Let's now try and connect to our RDS instance. So for that, let's launch our command prompt and navigate to my MySQL directory. So for me, it's in WAM64, the bin directory. Alright, now I'm in the bin directory for my MySQL installation. Now I will give the following command to connect to my RDS instance. So the command is mysql -h, which is the host name. So now I'll be entering the host name, that is the endpoint that AWS provides me on the console. So you'll select your RDS instance and you'll click on your endpoint and you'll hit copy. Alright, so once you've copied it, go back to your command prompt and paste it here. So the 3306 is actually your port name, so you have to enter it separately. So just delete the 3306 part and enter hyphen capital P. Remember guys, it's capital P, it's not small p. Small p is for password, capital P is for your port number. Alright, so you'll enter capital P and then enter 3306, which is your port number. Once you've done with that, then you'll enter your username. So for that, you will enter the tag as -u, which is the username. So if you guys remember, it's Edureka, followed by -p, which is the password, which we'll enter in the next line. So you will hit enter just after -p now. So in the next line, it'll ask you for enter password. Right? Over here, you will enter your password, which you have specified while in the installation. Hit enter, and if everything works fine, you will be connected to your MySQL instance. Yes, so we are connected to our RDS instance now. So you can enter the MySQL commands as you enter in your normal MySQL. So you'll enter show databases. So these are all the databases which are there for now on my RDS instance. So this is how you connect to your RDS instance once you have launched it. Let's come back to our presentation. So we are done with all the database services now. Let me give you guys a recap what we just learned. So RDS is a relational database management service. Aurora is a database which is built by Amazon, which is based on MySQL, but which performs 5 times faster than MySQL. All right. DynamoDB is a database management service for NoSQL databases. Elastic Cache is a caching environment. It is used to cache results, which reduces the latency and reduces the overhead on databases as well. Redshift is a data warehouse service which can be used to do analysis on data, and the data can be fed from RDS and DynamoDB as well. So guys, these were the databases service. Let's move on to our next domain. So our next domain is the networking domain. So let's see what all services are offered by the networking domain. So networking domain basically offers three kind of services: the VPC, Direct Connect, and Route 53. Let's discuss each one of them. So VPC is a virtual private cloud. So it's a virtual network. If you include your all your AWS resources that you have launched inside one VPC, then all these resources become visible to each other or can interact with each other once they're inside the VPC. Now, the other use for VPC is that when you have a private data center and you're using AWS infrastructure as well, and you want your AWS resources to be used as if they were on your own network. In that case, you will establish virtual private network, that is a VPN connection to your virtual private cloud, in which you have included all the services that you want on your private network. You will connect your private network to the VPC using the VPN, and then you can access all your AWS resources as if they were on your own network, and that is what VPC is all about. It provides you security, it makes communication between the AWS services easy, and it also helps you connect your private data center to the AWS infrastructure. So guys, this is what VPC is all about. Let's go ahead onto our next service, which is Direct Connect. So Direct Connect is a replacement to an internet connection. It is a leased line, a direct line to the AWS infrastructure. So if you feel that the bandwidth of internet is not enough for your data requirements or your networking requirements, you can take a leased line to the AWS infrastructure in the form of the Direct Connect service. So instead of using the internet, you would now use the Direct Connect service for your data stream to flow between your own data center to the AWS infrastructure, and that is what Direct Connect is all about. Nothing much further to explain. Let's move on to our next service, which is Route 53. So Route 53 is a domain name system. So what is a domain name system? Basically, whatever URL you enter has to be directed to a domain name system, which converts the URL to an IP address. The IP address is of the server on which your website is being hosted. The way it functions is like this. You buy a domain name, and the only setting that you can do in that domain name, or the setting which is required in that domain name, are the name servers. Right? Now these name servers are provided to you by Route 53. These name servers that Route 53 provide you are to be entered in the settings of that domain name. So whenever a user points to that URL, he will be pointed to Route 53. The work in the domain name settings is done. You have to configure the Route 53 now. Now your request has reached Route 53, it has to be pointed to the server on which your website is hosted. So on a Route 53 now, you have to enter the IP address or the alias of the instance to which you want your traffic to be directed to. So you feed in the IP address or you feed in the alias, and it's done. The loop is now complete. Your URL will now get pointed to Route 53, and Route 53 in turn will point to the instance on which your application or website is being hosted. So this is the role which Route 53 plays. It's a domain name system. So it basically redirects your traffic from your URL to the IP address of the server on which your application or website is hosted. Alright guys, so we're done with the networking domain. Let's move on to our next domain, which is the AWS management domain. So the management domain includes all these services. Let's start off with our first service, which is CloudWatch. So CloudWatch is basically a monitoring tool which is used to monitor all your AWS resources in your AWS infrastructure. Now how you can monitor them is, let's take an example. Say suppose you want to monitor your EC2 instance. You want to be notified whenever your EC2 instance's CPU usage goes beyond say 90%. Right? So you can create an alarm in CloudWatch, and whenever your usage will cross 90%, it will trigger an alarm, and that alarm in turn will send you a notification, maybe by an email or maybe whatever parameter that is set. You will receive an alarm in that scene. So this is what CloudWatch is all about. You can set alarms in turn to reactions that you get from your AWS resources. So our next service is CloudFormation. So CloudFormation is basically used to templatize your AWS infrastructure. Now, why would you templatize your AWS infrastructure is when you have different environments and you want to launch the same infrastructure in different environments, right? So if you create infrastructure and you don't want to create that again, you can always take a snapshot of it using the cloud formation, and then you can templatize this infrastructure and use it in other test environments. Say suppose you have test environment, prod environment, and dev environment, and you want the same infrastructure in all of these three environments. You can do that using CloudFormation. So CloudFormation is a tool using which you can templatize your AWS infrastructure. So nothing much more to explain. Let's go ahead and see our next service, which is CloudTrail. So CloudTrail is a logging service from AWS. So you can log all your API requests and API responses in CloudTrail. And why would you log them? Is because when you want to troubleshoot a problem. Say suppose you get some error while you are using your application, and since there can be numerous amounts or countless cases wherein you don't get an error, but in a particular case you get an error. Now you have to track down the problem. Now how will you track it down? You will track it down using the logging service. So since every request is logged using CloudTrail, you can go to that particular service or go to that particular log where the error occurred, and hence jot down the problem and jot down the line where the error is occurring and hence solve it. So this is what CloudTrail is all about. Now, how are the logs stored? Now, say suppose you have CloudTrail enabled on a particular service. So the CloudTrail will generate logs and will store those logs in S3, which is a file system provided by AWS. So this is how the whole process happens. Alright guys, let's move on to our next service now, which is AWS CLI. So CLI is a command line interface, which is just basically a replacement to the GUI interface that you have. I showed you guys the AWS dashboard, right? So that is the GUI. But say suppose you are comfortable with a command line. So you can also use a command line to deploy instances, and the way to do that is by using AWS CLI. Right? So there's nothing here to explain. It's just a replacement to your GUI that you use in AWS. All right. Let's move ahead to our next service, which is OpsWorks. So AWS OpsWorks is a configuration management tool. So it consists of two parts. It consists of stacks and it consists of layers, right? So layers are basically different AWS services that you have combined together. And when you combine them together, this whole system is known as a stack. Now, where would you need a configuration management tool? Now imagine a scene like this. You have an application which is using a host of AWS services, right? And you want to change something very basic. Now one way to change this thing is by going to each and every service particularly and changing that setting. The next way to do this is using OpsWorks. If you have deployed your application using OpsWorks, one basic setting that you have to change in all of your infrastructure can be done at the stack level. So basically all your resources, all the services that you're using are layers, there are different layers in that stack. And that combination is known as a stack, right? So that AWS infrastructure as a whole would be known as a stack. And if you have to change the setting, you have to change it at the stack level, and automatically it will be implemented to all the layers. So this is how OpsWorks function, right? It's a configuration management tool. All right, let's move on to our next service, which is the Trusted Advisor. The Trusted Advisor is just like a personal assistant to you in the AWS infrastructure. So how does it advise you is like this. So it advises you on your monthly expenditure. So say suppose there's a best practice, and if you use that practice, you can reduce your expenditure. So Trusted Advisor would advise you to do that thing. It would advise you for using your IAM policies. If it recognizes that a lot of users, a lot of different people are using your AWS account, and you have not set up any IAM policies on your AWS account, it will advise you to create those IAM policies, and hence this will enable you to create your AWS account better, right? And these are the kind of advices that the Trusted Advisor will give you in AWS. We are done with the management services. So our next domain is the security domain. So let's discuss the services in the security domain. So the security domain includes two services. The first service is IAM. So IAM is Identification and Authentication Management Tool. So what this basically does is, like I said, if you have an enterprise and you and your users are using your AWS account to control the AWS infrastructure, you can provide them with granular permissions. If say suppose you want a user to just review what all instances are there. So you can give him that access. If you want a user to just be able to launch instances and not delete them, you can give that particular user that access. So these are the kind of accesses that you can do give using IAM, and that is what IAM is all about. It authenticates you to your AWS account, or in this case your employees to the root AWS account in a fashion that you want. Alright guys, let's move on to the next service, which is the key management service. So AWS KMS is a key management service. So basically any instance that you have launched in an AWS is based on this infrastructure, that there will be a public key and you guys will be provided with the private key, and the public key is withheld with the AWS. Whenever you want to connect to your instance, you have to upload the private key, or you have to get the private key, and then AWS will match that private key with your public key, and if it matches, it will authenticate you to your AWS instances. So there's nothing more to explain. This is what basically KMS does. So KMS basically assigns you with a private key. You can create a new key pair or you can use an existing one. But guys, you have to be very careful with your private keys. If you lose your private keys in any case, there's no way you can gain access back to your particular AWS resource which will be used, which will be using that private key. So we are done with the security services. Let's move on to our next domain, which is the AWS application domain, right? So the application domain includes three services. The first service is the simple email service. So like I said, if you have a large user base and you want to send emails to them, you can do that on a push of a button using the SES. Also, if you want the replies to be automated, that can also be done using the SES. So it's a very simple service, nothing much more to explain. The next service is a pretty interesting service. It's called the simple queue service. So a simple queue service acts as a buffer. Now the way it functions is like this. Now say suppose you had that application, you had that image processing application, right? Now whenever you upload an image, say suppose you have to do 5 tasks. Now these 5 tasks will be listed in your simple queue service or your simple queue, and your server will keep a reference with this queue and see what all tasks are left to be done on the image. Now how does this help? This helps when you have multiple servers running for your processing, right? And say suppose your first 2 operations are done by the first server and the next 3 operations are maybe to be done by some other server, right? So the next server should know what all operations are already been done, and this knowing is actually referenced through your SQS. So whenever a task is done, that task is removed from the queue and the next task is queued, and that is what SQS basically does. All right, so let's move ahead. So the next service is SNS, which is the simple notification service. So it basically sends notifications to other AWS services. Now how can it be used? It can be used like this. Say suppose that application that we just discussed about image processing, you upload the image, right? And now you also want an email whenever an image is uploaded, right? Now how will you do it using SNS? So SNS will send a notification to SQS and SES that an image has been uploaded. Now, when the notification is sent to SQS, that notification can also include the number of tasks or the tasks that have to be done on that image, right? So SNS sends a notification to SQS with the details that have to be added in the queue. And SNS can also send a notification to SES that an image has been added, so send the respective email to the respective person. Right? So this is how SNS functions. It sends notification to different AWS services, and this is what SNS is all about.
So how does one choose a service? Well, there are quite a few parameters which one needs to consider. As far as the best service providers in the market is concerned, they consider these parameters. Customer friendly. It is very important that a service provider is customer friendly because different businesses have different needs. And if the customer needs are met, then the customer would be happy. And as far as the service provider is concerned, that is what the aim is. If you talk about Amazon, it has the best customer service, and Amazon proudly claims that if you've ever used one of their services, you'd know that we are the best service providers in the market. Next, we have transparency. Now, it is very important that your service provider is transparent. Now, what do I mean by this? What happens is most of the times people are forced to pay money upfront and then they're given access to the services. This does not give them any time or have any kind of demo with the services that are provided by the service provider. This is where AWS is different. What it does is it offers you free tier. Now, what this free tier does is it lets you use all of its services for free, and that too for 1 year. So you have sufficient demo or access to the services which AWS has to offer to you. And then you can take a call whether you want to go ahead and pay for these services or not. Pocket friendly. AWS is highly pocket friendly. Why am I saying this? Say for example, you have to go ahead and buy a server. Now AWS lets you have a server for 1 month at a meager price of $5 only. And this is highly affordable. So these are few of the important points which people need to consider when they go ahead and pick a service. And when you talk about AWS, it meets all of these needs. So let us move further and try to understand the different pricing fundamentals which AWS has. Now AWS considers these three fundamentals, that is compute, storage, and data transfer. If you talk about compute, what AWS does is it charges you on hourly basis. That is, you can use their compute and their processing services at a very less price, and also you'd pay only for those resources which you've used. And again, when you talk about time constraint, if you're using those services only for 1 hour, you'd be paying only for 1 hour. Next, we have storage. What AWS does is it charges you per gigabyte. That is, even if you use very less space, you'd be paying only for that space. And since it is almost as less as 1 GB, that is, you have to pay only for 1 GB, what this does is you don't have to worry about scaling, because if you're using more resources, you'd be paying accordingly. So yes, when you talk about storage, this is a very important point and AWS has it covered. Next, we have data transfer. Now, when you talk about data transfer, again, AWS charges you per gigabyte and it charges you only for the data that goes out. So yes, this again is an important point. And based on all these points, what AWS has done is it has gone ahead and it has built various pricing models. So let us move further and take a look at those pricing models one by one. Now, AWS has these three pricing models, that is pay less as you get more, pay as you go, and save when you reserve. Let's first talk about pay as you go. As I've already mentioned, AWS has a very flexible pricing model. Now, what do I mean by this? AWS charges you on hourly basis, plus it charges you only for the compute capacity and the resources which you're using. So if you need a particular resource for 1 hour and you need n number of or n amount of compute capacity, you'd be paying only for that thing. Say for example, your requirement is 40 GB for first month, but what happens is you end up only using 10 GB. Now in this case, your 30 GB of space is wasted, and this is when you pay upfront. But if you're paying on hourly basis and only for the resources which you're using, you're actually saving up all the cost which you would otherwise pay. Secondly, we have something called as pay less as you get more. Yes, more the services you use as far as AWS is concerned, it charges you fairly less. You have a chance of saving up to 70% of your total cost, and that is a very nice feature to have. You also have something called as save when you reserve. Now, if you know how much resources and the compute capacity that you're going to use in near future, what you can do is you can go ahead and reserve these services in advance. Now, in that case, AWS charges you fairly less compared to the other models. So let us go ahead and take a look at these one by one. Firstly, we have no upfront costs. Now, what this means is you can go ahead and reserve your resources and your services in advance, but you're not paying anything. But what happens here is you're paying an amount which is lesser than the previous two mentioned models, that is pay as you go and pay less as you use more. But this thing is still costlier compared to the other subtypes of this model, that is partial upfront cost and full upfront cost. Now, when you talk about partial upfront cost, you're paying a partial lump sum amount which is less than the total amount, and you're reserving all your instances and all those things. But this is comparatively affordable when you compare it with no upfront costs. It is, however, costlier than the last one, that is full upfront payment or costs. In the last point, that is full upfront costs, what you do is you decide, okay, these are the amount of resources which I'm going to use, and this is the compute capacity which I need, and accordingly you book all those resources and you make an upfront payment. Now, since you're making an upfront payment, this is the most affordable of all the pricing models that are there. But for this, you need to be assured that these are the minimum resources which I'm going to use, And if required, I will have to scale up, but not scale down. So this is about different pricing models as far as AWS is concerned. So let us move further and try to understand the next point. Now, how does one go ahead and calculate the savings which one makes? Well, AWS has provided you with an AWS calculator. Now, what does this AWS calculator do? It lets you calculate your monthly expenses. That is the services which you've used and all those things. Hence, you can keep a track of all the money which you're supposed to invest. Apart from that, it also provides you with various templates which lets you appraise your complete solution. There's one more variant as far as the calculator is concerned. It is called as TCO, that is total cost of ownership. Now it is little different than the normal AWS calculator. What it does is it basically lets you calculate or compare one service's price with the other service. It also lets you compare the infrastructure solution which AWS has to offer to you, and this might vary from business to business. So when you talk about the total cost of ownership for which you might invest, this is the calculator which you should go for. Now, when you talk about the AWS calculator or the TCO calculator, I would be giving you a small demo, or once I walk you through the AWS website, I would be telling you as in how do these calculators work. I hope this point is clear to all of you. So let's move further and try to understand the next point. Now, AWS also has to offer you a free tier, which I mentioned in the past. So let us move ahead and try to understand what this is exactly. Now, as I've mentioned, AWS has various services to provide to you, and those services will have the subtypes as well. So all these services are available to you for free for 1 year, and this is the access which AWS provides to you. Say for example, you have a service called as Amazon Elastic Cloud Compute. This is one of the most popular services as far as AWS is concerned. And when you talk about its access, what AWS does is it lets you access 750 hours of this service on any of your OSs, whether it's your Linux, whether it's your Windows, you can have access to this thing. And when it comes to using this service, 750 hours is sufficient if you're trying to get started with AWS. Then you have other services like Elastic Load Balancer, you have Elastic Block Storage, you have Amazon Web Services. And based on the usage, they have different capacities which are made available to you for free. Now, AWS won't charge you for any of these things. And when you need a demo, I feel these resources are more than enough. Again, once I switch into the website, I would be talking about the free tier as well. So let's do one thing. Let's actually go ahead and first take a look at these resources or these services one by one. That is, let's try to understand what free tier is and what these calculators are with the help of the AWS website. So what I'm going to do is I'm just going to go ahead and switch into the AWS website. So yeah, what I've done is I've actually gone ahead and I've opened AWS free tier. Now this is what it looks like. Basically, these are all the resources which it has to offer. But before we do that, what you need to understand is you need to create an account here. To do that, you'll have to go ahead and enter your debit card or credit card details. Now, AWS won't charge you as long as you use all these services in the limits which AWS has mentioned. And to be honest, those are fairly large limits. So you won't be exceeding that if you are just using or having a demo of these services. So how does one do that? One goes ahead and gives in their credit card or their debit card details. AWS will charge you $1, that is 1 USD, for some verification purpose, and within 10 minutes that amount would be refunded back into your account again. So this is only for the verification purpose, and after that if you overuse the resources, then AWS would charge you. So what you have to do is you have to just go ahead and create an account here. Now these are the free tier services which AWS has to provide. It has something called as Elastic Cloud Compute, that is EC2, and as I've mentioned, it has 750 hours of it. You have Amazon QuickSight, which is used for analytics basically, and it is available in 1 GB of your Spice capacity. Now, I won't get into the details of what Spice capacity and all those things are. You have something called as Amazon RDS, which is for storage, and again, it provides you with a capacity of 750 hours per month, which is again very high. You have Amazon S3, you have Amazon Lambda. Now, these are fairly popular services, and as far as the space or the capacity which is mentioned here, it is more than enough or sufficient. AWS also provides you with various tutorials that will help you get started here. So if this is your concern, I would suggest that you just go ahead and log into AWS's website, have an account there, and you're good to go. As far as once you sign in, how it looks, I'll show you that as well. You can just go ahead and log in. Now I have an account already on AWS. There you go, it takes eternity. Yes. So once you log in, this is how it looks like. You can go ahead and you can actually create your own instances and all those things. Say, for example, you have something called as EC2. You can go ahead and you can specify all the details, as in this will show you how many instances are running and all those things. For now, there is nothing that is running here. So there's 0 instances that are running. So you can actually go ahead and create your instances and do all those things. You can launch your instances, say, for example, and you get to select as in what OS and what all do you need to do for it. So yes, but then this is not the discussion for today. So I'll just go ahead and skip this part and I will switch to something called as the calculator. As far as the free tier is concerned, these are all the services that are available to you and you can actually go ahead and use those. Now next we have something called as our simple monthly calculator or AWS calculator. Now it gives you your monthly estimate as in for all the services which you've used. All you have to do is you have to go ahead and add the details as in what is the description, how many instances are you using, its usage, and the type of the instance. Now the T1 and all those, the micro instances and all those, these are the details that have been covered in a session called as AWS tutorial by Edureka. If you want to have details about those, you can actually go ahead and view that video as well. Now this is where you talk about the billing option, whether it's on demand and all those things. You're free to go ahead and choose a plan for you. As you can see, it's visible here. And once you do that, once you've filled in all these details, your storage, your compute capacities, your elastic IPs and all those things, you finally need to come here and you just need to say that there's an option here which actually lets you submit all these values. And once you do that, you'll have the final result as in, okay, this is your usage till time and this is the predicted usage and all those things. Then you have something called as your TCO. Now this is more global or more general kind of an application. Now, this is something that deals with your interim expenses and all those things. This is for the overall expenses, as in the total cost of ownership. You can select the currency here, as in you have an option of paying in different currencies. Since it's a global leader, you have options to pay in different currencies as well. Say, for example, you're somewhere in India, you would be paying in rupees, and you can select that option here as well. Apart from that, what is the environment which you need to compare it against? Because yes, as I mentioned that you can compare different architectures, so you can go ahead and select that as well. You have various other features. Say for example, you can go ahead and put in the details for the servers, whether those are physical servers, virtual servers and all that. Your storage. Now there are storage types here. Say for example, you have SAN, you have NAS, you have object. You just need to fill in these things and then you need to calculate your TCO as well, and you'll have the total cost of ownership too. So these are different calculators, and this is how the free tier as far as AWS is concerned works. So you're actually free to go ahead and explore these things because it is available to you freely and you can just have access to this and get the know-how as in how AWS works. I hope this is clear to all of you. So let's move further and continue with our discussion as far as the pricing video is concerned. Now that we've understood what the AWS free tier is, let us move further and consider this final point of discussion, that is cost optimization. Now this is a very important point. As I've already mentioned that money is very important when you talk about businesses. It is also very important that you are able to optimize all the money that you are investing in various projects. Now this is where AWS is very good because it helps you optimize your cost a lot. Yes, it has great pricing models, but apart from that, it also lets you use those wisely so you can optimize your cost. Let us take a look at these points one by one. Right size your services. Now, as I've mentioned, it is easier to upscale, but it is not easy to downscale. So it is always wise to start with lesser resources and lesser compute capacity. So this is where right sizing becomes very important. And AWS lets you do that. Since I've mentioned that it has highly flexible pricing model, you can actually go ahead and choose minimum resources, start with small, and then upscale according to your needs. We also have something called as reservation benefits, which I've again discussed in the past. You can go ahead and choose the models which actually meet your requirements, and you can actually go ahead and reserve few of the resources upfront, which you're very sure about. And yes, you end up paying less again. Elasticity benefits. Now, what AWS does is it provides you with various tools. It also provides you with something called as scheduler. Now, these time schedulers, what they do is they let you switch off and switch on your various resources that might fluctuate when you talk about their usages. Say, for example, you have services like EC2, RDS. Now, these are instance-based services. And when you talk about their usage, that might not be constant throughout the various hours of the day. So you can decide to switch off and switch on these resources so that they're used optimally, and you end up paying only for the hours for which you've used those services. So this is where time schedulers do come into picture, and this is where AWS has great elasticity or great flexibility. Finally, in this list, we have something called as track and manage services. Now, AWS provides you with various tools and softwares that actually go ahead and let you keep track of all the real-time usage and measurements that you're concerned with. Now, what this does is this actually helps you optimize your usage. How? Because there are tools that let you build real-time dashboards and all those things. Now, since you have those, you can analyze all the traffic, all the data, and all the resources which you're using. And thus you can cut down on a lot of cost, or you can just go ahead and optimize a lot of money and cost that you're investing in your projects. So these are the points that are very important when you consider cost optimization. And this was probably the last point when you talk about our today's session, that is AWS pricing. So if you're concerned about going ahead and picking a proper cloud service provider, I would say that choose AWS, and it would definitely ensure that you sleep with a lot of cost optimized. I hope you had something new to learn from this session. As far as this session goes, this is the end of it. Thank you. Bye bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!